Recording in progress. Good morning, everyone. How are you today? All right, we're going to make a start this morning. So top of the morning to you who are joining us here in my beloved country, Guyana, or I would usually say in the 592. And also a top of the morning to those who are joining us online via Zoom and via our streaming platforms as well. Before we begin, as many of you may have joined us today, and also I do believe I'm not seeing any new faces, but just a reminder. Oh, yes, some new faces as well. So welcome. Just a reminder to those who are also new here, if you could follow the exit signs in case of any emergencies. This is a no smoking zone, so you can head outside as well. If you do need to take a break, you're allowed to do so, but inside you cannot. But nevertheless, we're still here to have that conversation rolling. So once again, I'd like to say good morning and welcome to the second day of the 20th Caribbean Internet Governance Forum, taking place, like I mentioned, here in Guyana. I am Jennifer Prasad Budu. I will be your host for today, or rather your moderator for today, and allow me to make some housekeeping announcements to our persons who are joining us online for the webinar. To interact with our speakers today, kindly use the options available in your Zoom panel, generally located to the base of your window. To comment on the session and share your thoughts, we ask that you use the chat where you can speak with other attendees. As the webinar progresses, we ask that you, if you have any questions, to be placed in the Q&A for ease of locating them. Questions placed here will be directed to our panelists. We ask that the conversation, comments, and questions posed to the professionals on topics today must adhere to the code of conduct as well, and we thank you in advance for following these rules. Should you experience any difficulties, please email us at events@ctu.int for assistance. Also, please note the presentations and the bios of the speakers during the CIGF and CYIGF can be found on our website at www.ctu.int. Also, for those who are joining us here and for those online, we'd like for you to fill our evaluation form of yesterday once you were present yesterday. And we also invite you to fill the 2 evaluation form at the end of the event. We want your honest truth, so we're looking forward to see that. Before I hand the mic over to our esteemed head table, I'd like to talk about a little story about the importance of the internet and why we should trust it. So back then in 2007, while I was pretty young, I'm sure many of you are also pretty young back then too, 2 friends, Brian Chesky and Joe Gibber, were struggling to pay rent in San Francisco in the USA. They had an idea to make some extra money, and we all like to make extra money as Caribbean people, of course. And they were thinking, they had some ideas. They thought, let's rent out or air mattress in their apartment to people attending a local conference. They called it Air, Bed, and Breakfast. Initially, they had trouble getting traction, but they didn't give up. They persevere, and it's important that we do so. What turned things around was their clever use of the internet. They created a simple website, posted attractive photos of their space, shared their story online. They tapped into social media, online communities, and blogs to spread the word. Slowly, people started to book their space. Realizing the potential, they expanded the concept to include other people renting out their homes or rooms. In 2008, not so long ago, they officially launched Airbnb. The internet, ladies and gentlemen, and for those who are joining us online, played a crucial role in their growth. By leveraging online platforms, they could reach a global audience, attract investors, and build a community of hosts and guests worldwide. Today, many of you may have used Airbnb as well. Today, Airbnb is a multi-million-dollar company operating in more than 190 countries, including my beloved country, Guyana. We can say that it has revolutionized the way people travel. It has revolutionized hospitality. And we can also see that persistence and strategic thinking and the use of the internet and what it can do. I do believe many of you here can agree that this is a story of testament of how the internet can turn a simple idea into a global success, empowering people like you and myself to build, share resources, connect. We must connect like what we're doing now online, and also to build businesses that change worlds. And many of you may be thinking, how is that important to today's? Well, it's incorporating trust into the internet. It's showing that the foundation of trust. It's also showing that through trust, transparency, and accountability, these things can happen, and the importance of internet governance connection. I mean, it could show so many things, including trustworthy information. And we could see that today is a testimony being in over 160 countries. Ladies and gentlemen, I hope that story is something that you can think about today as we continue the conversation. I would like to now invite Rodney Taylor. Rodney Taylor, before I do so, today we're going to focus on the Global Forum for Cyber Expertise Internet Infrastructure Initiatives, otherwise known as the GFCE-III. I'd like to now officially introduce no stranger to the panel, Mr. Taylor, to do his welcome remarks for today's dynamic conversation. Ladies and gentlemen.
Thank you very much, Jennifer. Good morning, everyone, and welcome to day 2 of the 20th Caribbean Internet Governance Forum. Very pleased to welcome you on behalf of the CTU Secretariat, and I'm really looking forward to today's session. First, formal jointly hosted workshop with the GFCE. We recently joined as members of the GFCE as part of our capacity building efforts at the CTU to ensure that we have the skills and the knowledge to effectively advise our governments and to secure our critical internet services. We look forward to working in the long term with GFCE on these capacity building initiatives, ensure that this will be the first of many such engagements. Martin, who's sitting to my left, will tell you a bit more about the III initiative and how it enhances justified trust, what they've been doing and what we will be doing here today. We have a very packed program. Many of our partners as well will be speaking, including ICANN, which is, as you heard yesterday, the Internet Corporation for Assigned Names and Numbers, the American Registry for Internet Numbers, the Latin and American Internet Registry as well, LATNIC, as well as several other partners. We'll be presenting also on a project that we've been working on, a DNS Observatory for the Caribbean. And Mr. Shernan Osepa will tell you about that. He's a project lead and also a consultant with the CTU. We will be having some presentations as well from the Internet Society. Nancy Kuras is here with us throughout the course of this week. The Global Cyber Alliance, as well as we have at the end of the session, well, actually just before the end, we also have a presentation from Identity Digital on good practices for securing resilient operations for CCTLD registries. We'll close off the session today with some special presentations from Meta on data for good, and also from the UN Office on Drugs and Crime on a CSAM initiative, status of the child sexual abuse material, and policy actions to address this within the region and globally, and also a presentation on the UN Convention on Cybercrime. So, as usual, we want this to be a very engaging session. We're not here to lecture, we're here to interact, to hear from you, to share with you, and we invite you to participate. A special welcome to our online attendees. We expect those numbers to grow. But welcome and thanks for joining us on day 2. I'm pleased to introduce Martin Borteman, who spoke yesterday. He is an ICANN board member and the chair of the GFCE Working Group on Emerging Technologies. He's a strategic advisor, facilitator, and moderator with over 25 years of experience in guiding governments and global businesses on the economic, social, and environmental impacts of current and future internet innovations and technologies. I'm pleased to hand the floor over to Martin Borteman to take us into the Triple I workshop.
Thank you very much, Rodney. Thank you for having me here and for this collaboration with the Global Forum of Cyber Expertise. Let me take you very quickly through some of the highlights of why Global Forum for Cyber Expertise is doing this. And I'm trying to launch the presentation now. Yes. So the Global Forum of Cyber Expertise is already about 10 years ago set up by a number of members consisting of countries and major global players to really help the world in capacity building in the internet, recognizing that this internet is something to be shared by the world, and the world is not all going at the same speed. The Triple I specifically is in that focused on improving justified trust, and I should probably turn on my clicker to work. Yes, my fault, thank you. So the aim of this initiative that we talk about today is to help to build a robust, transparent, and resilient internet infrastructure. One thing with the internet is you need to have access. But as soon as you have access, you're a member of a very sophisticated network of networks with people with different skills and capacities all over the world. So rather, it's important to stand ready for that. So being able to make sure that the internet and the way you use it in your region is actually as safe as possible will help to enhance justified trust in that infrastructure. And with that, you can better benefit from the possibilities that the internet offers. So we do this together with the region and global experts as well as regional experts to make sure that we get the best out of it together. And you see a couple of these people will speak up on behalf of their organizations today with a lot of depth and knowledge behind it. No doubt you can follow up later. We have people in the room as well from some of these organizations, Albert Daniel from ICANN and Nancy Quiros from ISOC. Speak with them if you have questions, and you can always send an email to me or any of the speakers. You can find them online nowadays. So most importantly, if you want this internet to function, standards matter. The internet has been built up and many years ago, 50 years ago, TCP/IP actually, for me, was the foundation of the internet as we know it, because that is what ensures interoperability between all these internets that together form this big global internet with more than 5 billion users. Modern internet standards, so for generated over the last 10 years or so, include a security component that goes well beyond the original standards that didn't foresee this. Nobody knew at the time that the TCP/IP was invented, that the World Wide Web started, that the internet would become as important as it is today. Being more important, being robust and resilience is even more important. Same goes for email. So what you see is a number of standards that are important in this, and I won't spend more time because the speakers will take you deeper into this. Improving justified trust in using the internet and email in the region. This is a picture from the first day when I was still young and didn't have a beard before COVID. But this purpose stands. This purpose is what makes this day so important and useful to go. 11 events so far, number of them in India, in Africa, in Asia, and in Central Europe, Kazakhstan. Always with the local actors as well as with global knowledge. You can find the reports on these meetings as well as an overview of the presentations back on the website of the Global Forum for Cyber Expertise under III. So this is how we do it. We basically have 3 blocks. The block 1 is better use of today's open internet standards, and we'll start with that in 2 minutes. Block 2 is inspiration and practices that can help you to go beyond the standards itself, but also act, organize yourself, and take specific measures for specific purposes. Any problem you run into in your country today is a problem already somebody else has run into before, and there's answers. So let's learn from that and build that knowledge base together. The third one, the blue one, is the block action planning for a more trusted internet in the region. This is where we'll invite you all to really engage and talk with us about what can be done, what should be done, what are the priorities here, what are we willing to commit to take action on. So with that, I'd love to invite our first speaker, who will focus on DNS, domain name security, from ICANN, Mr. Nicolas Antoniello. Please, Nicolas, can you help with the presentation for Mr. Antoniello?
Hi, Martin. I'm not sure if the audio it's okay. Can you hear me?
We can hear you very well. Welcome,
okay.
Nicolas.
Thanks very much. First, I would like to first introducing myself. So my name is Nicolas Antoniello. I work at ICANN. My role at ICANN is I'm the regional technical engagement manager. That means that I'm kind of the link between the ICANN org and the different communities, or in general the internet community, whether they are from governments, whether they are civil society, education, whatever, in technical matters. So I'm kind of the link between the org again and the different stakeholders in technical matters. Most of the time I do capacity building and also other tasks related to the ICANN remit and our day-to-day work. So thanks very much for the invitation to participate in this panel today. I'm going to go quite fast, but I'm going to try to make it clear and easy to understand to anyone, no matter if you are an expert technician on internet and networking and DNS matters. You may get a little bit bored at some point, but if you are able to also get something from what we are going to go to. First up on how internet works. Internet was in some time ago. I don't say long time ago because I always say that the first generation it's still here. The first internet generation is still here. So most of the people that invented, most of the people that developed the internet in the different countries all around the world are still around us. So we are just about to reach the generational change between the first internet generation and the second one, and that's something very important from the internet policy making perspective, and also that's a very important it's a very important times for the internet, as we are changing the generation, and we will have to succeed in translating all the knowledge and all the processes that are undergoing that make the internet works to the new generations. And I think that's part of what you are doing in today or this week in this IGF event, right? So internet was invented, right? the main invention wasn't, for me, it wasn't the internet itself, but the ability of devices to interconnect and exchange information without the need of putting information into a disk or whatever means and take it to the other device, to the other computer or to the other device, right? So now devices are all connected through what we call internet, which is not much that a big network made of smaller networks that again are made of smaller networks and again and again and again. So you have a bunch of devices in networks all together. They form the what we call the internet. Okay, those devices have to communicate, have to exchange data among them. In order for the devices to be able to exchange data, we need a way, a means to identify these devices in a unique form, right? Because if you cannot identify a device as a unique device in the whole internet, you won't be able to exchange data to communicate with that device, right? It's the same as I always make the parallel with the telephony, right? You need, in order for you to call someone else using the telephone network, you need to know the identifier, the unique identifier of the one you want to communicate to. That's the telephone number. For the internet, the unique identifiers are what we call IP addresses. Okay, so devices have IP addresses, and we use these IP addresses in order to uniquely identify those devices within the internet. There are flavors addresses. One corresponds to the so-called IPv4, and the one that is still mostly used since the beginning of the internet up to these days. And the second flavor is what we call IPv6, which is a different protocol. Unfortunately, the ones that made the protocol call it version 4 and version 6, IPv4 and IPv6, but they are not really versions of a protocol, but a new protocol. So we have IPv4, we have IPv6. Any of those protocols is used mainly to uniquely identify devices within the whole internet. Okay, so we have a lot of devices, each one identified with an address that corresponds either to protocol IPv4 or protocol IPv6. That's the IP address. So the IP address is the unique identifier of a device within the internet. But what happens with that addressing scheme? Someone realized that the same as happens with the telephony network, that for the human brain in general, it's more difficult for us humans to remember numbers than to remember sequence of words. So for me, it's very easy to remember the name of most of the people I know. So I can meet and say, hey, hi, Martin, how are you doing? I remember Martin Botterman names, surname, everything. But I don't have any idea of Martin's telephone number. Now I even don't need to remember Martin's telephone number, but if I want to remember, I can remember 1, 2, 10 telephone numbers, but not more than that, okay? So of those devices I want to communicate to, it's very difficult for a human to remember all the identifiers, all the IP addresses of those devices. What is the solution for that in the telephony network? In the telephony network, we have the telephony directory, the directory, right? When you have the name of the person and the associated telephone number. So each time you want to communicate with someone, you just look at the name, you have the number, you use that number to start a communication, an exchange of data with that phone. In the internet, the exact same idea was developed by the use of what we call the domain name system. So the domain name system was created in order to associate those identifiers, those IP addresses, with names that are easier to remember. Of course, it has other technical advantages using that translation system. But the main idea behind the domain name system when it was created was to make it easy for people to remember how to communicate with the different devices connected to the internet by only knowing the name of the device. So you have the name of the device you want to communicate. You need the IP address in order to communicate. What do? You use the DNS. So first thing you are mostly likely to be doing when you are starting to exchange data with any device connected to the internet, whether you are accessing a web page, whether you are establishing a conference call, like this one, like this Zoom call, whatever you are doing in the internet, the token that you know, the thing that you know is the name, you need the IP address. And so the first thing you're going to do is to do a DNS of this name, and I want to know the IP address corresponding to this name in order to be able to communicate with that device. So you send that question to the DNS system, and eventually the DNS system will return an answer to you that will say, okay, this is the address that corresponds to the name you gave me. Then you use that address to start the communication, to establish the communication with the other device. Again, whether you are downloading a web page, accessing a website, establishing a conference call, whatever activity you are doing on the internet. So that's the main idea and the main use behind the DNS and the reason that the DNS was created. So the DNS is a big database that holds names and numbers. Now, which numbers? IP addresses. Which names? What we call domain names. So it associates domain names to IP addresses, okay? How it works. DNS has mainly two types of servers. So there are mainly two types of equipments that form the DNS ecosystem. One type of equipment is what we call DNS authoritative server. So a DNS authoritative server is a server that has part of the information of all the DNS ecosystem. So the DNS database is not concentrated, it's not the whole DNS information. So there's no one single server holding all the translation between names and numbers. That information is spread all over the world in hundreds of servers, or more than hundreds, or tens of hundreds of servers around the world. So each of those servers holding a bit of information from the whole DNS database is called an authoritative server. Okay, so the DNS is basically a bunch of authoritative servers that work all together to form what we call the DNS database. Okay, those are the servers that hold the information about the translation. And there are other type of server that is called recursive server. The recursive server is basically a server that is made to do the search. So when any device wants to know the address corresponding to a domain name, it doesn't need to be the self device, the one that makes the search for the answer. Instead of that, the device will send the query, will relay the query to a recursive server, and the recursive server is in charge of searching for the information. Once the recursive server searches and gets the information from the correct authoritative server, this recursive server will send back the information to the device that asked for that for the information. Okay, so authoritative servers, they hold the DNS information. Recursive servers, they search among all the authoritative servers for a certain information, a certain translation between a name and a number. The original DNS protocol wasn't designed with security in mind. Why? Because Internet wasn't designed with security in mind. Internet was, at the beginning of the Internet, everything worked mainly on goodwill and good disposition of the people in order to make things work. So people were technicians that run networks, and they want to make this work this new thing we call the internet work, and they work all together. And there weren't mainly there weren't big cybersecurity threats. There weren't security issues. Privacy wasn't also a concern at that point. But as internet became what we know as internet today, which is huge, bigger than what they have thought at the beginning, of course, many issues and many concerns arises with that. And internet now, it's the platform where all the economy, the social life, the health, and many big parts of our lives go through the internet or use internet as a platform. So there are many things that are happening there. Of course, there are threats now. There are big security threats. There are some that are bigger. There are some that are not. There are privacy concerns, etc., etc. In order to add to the original DNS protocol, some of those features like more security, more privacy, etc., etc., other protocols were developed and somehow attached to the original DNS protocol. One of these protocols is called DNSSEC. So what does DNSSEC do, right? DNSSEC, it's a protocol that provides some level of security. It's not the solution to all security problems that may arise related to the DNS, but it solves a lot of them. DNSSEC, adds, as I was saying, DNSSEC adds security between these two types of DNS server. So DNSSEC adds security not between the end user device, but between the authoritative servers and the recursive servers. When the recursive server receives a query from a client, from a device, and starts searching for that information, in order for the recursive server to search for the information, it has to exchange data with different authoritative servers. In the original protocol, that data that is exchanged between the recursive server and the authoritative servers had no security. If you deploy DNSSEC, every time an authoritative server sends information to the recursive server, it will digitally sign that information. So what is DNSSEC? It's basically adding a digital signature to every single information that the authoritative server sends back to the recursive server. And what can we do if I now have a digital signature for all the information? Well, if I have a digital signature, I have all the advantages that a digital signature provides. One of the main advantages is that I can make sure, if I can verify that signature, I can make sure that the one that sent me the information, it's the one that has the authority for that information. And it's not basically a fake information or a false information or someone that gets in the middle of the transmission of the information and changes the information. Because if someone pretends to be the authoritative for the information, or someone gets the information and changes the information, when the recursive server gets the information and the signature and tries to verify the signature won't verify. If the signature won't verify, then the recursive server will be sure that something is wrong with the information. That's not the original information. That was tampered, or it's falsified, or whatever. So by the use of this digital signature, which is what DNSSEC protocol adds to the DNS protocol, the recursive server can authenticate the information from the authoritative server. In practical terms, what does add to our day-to-day? Okay, I always want to use this example. Let's pretend that we are accessing our bank account, right? We type our bank URL in the browser, and we access a username and password. The username could be my DNA or whatever, and the password, extreme complicated password, in order for to make it easy for attackers to guess my password. Digits long password. It's very long password. And I type my username, my password, and bluff, I get into my bank account. I do all everything, anything that I want to do, like transferring money, whatever, paying for stuff, whatever, and then I disconnect. Okay. If I have DNSX, what can happen eventually if the attacker is enough? Someone can tamper with the DNS server, for example, or with the DNS information. When I type the URL of my bank, if the DNS returned an IP address which is not the IP address of the real bank server, but an IP address of a server set up by an attacker, the attacker creates a web server that looks exactly the same because he copy-pastes exactly the same bank account page that I should get from the original bank. And we have two servers, the original one and the attacker server. They look exactly the same. I do the DNS query in order to get the IP address of the bank, and then I end up in the server of the attacker, and then you know the rest of the story, right? The attacker will get my username, my bank account password, etc., etc. If I have DNSSEC in place, when I do the query and I get the IP address, if the resolver can't verify the signature, the digital signature, the resolver won't send me the address of the false server. In that case, will send me an error message telling that something is wrong, and I can guess that is due to, for example, a false DNS response or a tampered DNS response. So it's very important that we kind of deploy all these protocols that were added to the original protocols, in this SEC protocol that it was added to the original DNS protocol, in order to add, in this case, security, kind of origin validation, in this case for the exchange of data between the authoritative servers and the recursive servers. There are other protocols that you can also deploy and implement that may add other security, may solve other security issues that may arise from the DNS, or make use of DNS to perform attacks. There are other protocols that you may deploy that add privacy, not only security but privacy. And there are other protocols that you may deploy that make the whole system more reliable or more resilient, etc., etc. Okay. I don't know, Martin, if there are any questions from the floor.
So thank you, Nicholas, for explaining how the DNS works, and also why it's so important to use DNSSEC to ensure that the integrity of the origin is very well protected. And I really appreciate all the work done. One of the things that we do as well is that this means there is a kind of encryption involved in DNSSEC, and we are currently looking very much into how we can make sure that's also crypto proof of quantum proof, and we're working on that. So for reports on the work, you can also go to ICANN Octo and find more. So if you can hang around, then we'll move to the next speakers. And then at the end, we hope to still have time to go into some questions. Is there an urgent question for clarification at this moment? If not, then thank you, Nicholas, for explaining this so clearly, and asking Joseph to talk us through what we can do to enhance email security. Thank you very much. Joseph, welcome.
Thank you so much, Martin, for the intro and inviting me here to speak. Yes, I've prepared the presentation here. I would like to share that. Let me go ahead and get that started here. Okay, I hope That is good. Everyone can see that.
It looks very sharp. Thank you.
Awesome. Okay, so thank you so much for having me. I'll be talking about email security a little bit, especially on the protocols of SPF, DCAM, and DMARC in that order, just to understand how everything ties together. I would like to start with SPF. So what is SPF? SPF is actually one of the oldest protocols for email security there is. It was introduced in 2003, and the idea behind SPF is to give the admin the ability to safe list servers or IP addresses, SMTP servers they are, IP addresses in a DNS TXT record, kind of like an allow list that is saying that these IPs or servers can send out email from my domain. That is the idea behind it. Now, whatever that record includes, the record, by the way, we have an example in here. This is what it looks like. And an SPF record can only be a single record per domain or a subdomain. When I say that, I mean on a same domain level, you cannot have more than two. But if you want to add a separate one for a subdomain, you can have it, since SPF records are not inherited from subdomains to their parent. So you can have separate records, but the rule is under the same host name, there should be one. And that single record should include all the IP addresses that you are safe listing. In the example in here, we can see that it's not only IP addresses, there's IP4, IP6 in there, but we have also other mechanisms like include or MX. So I'll go through them. Let me quickly explain what the record is, the structure of it. So at the beginning of it, we have the version tag. It says V equals SPF1. This is the standardized version of SPF. This is what this is how the server will recognize that this is an SPF record. So it can pull it from the DNS and then look into the information or the entries or the data that it has. Some of the examples of their mechanisms, for example, the MX one. What this means is you're safe listing all the MX servers that you have. An MX server is it's a separate record in the DNS, but those are the servers to receive emails inbound. But for outbound, when you input this in your SPF record, you're also allowing those servers to send out emails from your domain. So that's what this one means. And include, which is generally the most common mechanism that is used globally, is the values for it is either like a subdomain or a domain. And what it refers to, what it forwards to, is the another SPF record that is hosted underneath it. So for example, when you get a domain set up to use Google, let's say Workspace, Google, during the configuration for SPF, will provide you a single include mechanism. The reason behind that is underneath that single mechanism, Google will manage all the IP addresses, the rotation of those IP addresses from their side. So whenever they decide to remove an IP or a server and add a new one, you wouldn't have to do any changes from your side. It's automatically applied to it since the request is getting forwarded to them. That is the main idea behind it. And that's why majority of ESPs, when you try to configure SPF, they will provide you an include to add. And IP4 is another very common one. The IP4 or IP6 is the end value that any of these mechanisms will resolve to. So the MX one, it's going to let the server look up the MX in the DNS and then find the IP address. IP address is either IP4 or IP6. An include underneath it will have multiple IPs And again, they're going to end up being either an IP4 or an IP6. So by adding this, you're directly adding the IP address in your SPF record. So if there's like, for example, internal servers that you have, in-house servers that you manage, and you want to also safe list those and configure them, you just add them as an IP address. And then the last one that we have here, this would be kind of like the policy for SPF. You have multiple options for this. Two of the common ones would be soft fill and hard fill. The hard fill would be this, it says line all. Soft fill would be a tilde-all. What the line all would do is if an email is failing SPF, it would reject the email, send it back, whereas a soft fill will report it as a failure, but it will not do anything to it. At least that's what the protocol is meant to do. Nowadays, it's also very important to mention that a hard fail false policy is not very respected by servers, just because there's DMARC to take care of the policy enforcement things. So they decided to kind of disable this SPF separate policy and let DMARC do the policy handling and enforcement, which I'll go over shortly here. So moving into the next step, and this is one of the most important things to mention about SPF, is there's two separate from elements in an email header. There's the from, which is the header from, and then there's also the mail from address. Now, which domain would the server pick up and look up its SPF record? That would be the mail from addresses domain part in here. So the original from, which is what you would usually see in the UI, is not the one that the server will pick and look up its SPF record that is hosted. And the reason that I'm mentioning this is because this is one of the shortcomings of SPF, because it's very easy to modify any of these addresses. For example, someone can modify the mail from address, and then in the from address, it would say something else, which I do have an example in here. So let's go through this. This is a very basic email spoofing attack. And if we look at this, the from address is bbc.com. Again, this is spoofed. So the mailed by address, which is the mail from, also known as the return path address, is something else. So what this email or the server is doing is it's picking up the SPF record for this domain, authenticating it, putting it as an SPF pass. But in fact, this is what's getting spoofed here, bbc.com. Whereas now you have a SPF pass while spoofing bbc.com. And this is where the shortcomings for SPF start. So up next, let's discuss DKIM as well a little bit. So what is the idea behind DKIM? If we want to compare these two, SPF is based on kind of authenticating the server that the email came from, while DKIM is much more focused on the integrity of the email or the message. So the idea behind that is you have two separate keys. One of them is in the server itself that is sending out the email, which is known as the private key, and another one hosted in the DNS, which is known as the public key. And this goes for each platform, or if it's like an in-house server, it's going to be separate, depends on the configuration. So you're going to have multiple DKIM records in the same DNS zone, differentiating with everything, the platforms that you're using and whatnot. So the private keys, again, stored in the email server configs, they are used together with the public key to sign an email. And when they do sign it, they create a new header element known as a DKIM signature with the hash value. and they append that into the email header. What the recipient side does is it uses the same public key and the DKIM signature to decrypt and make sure that the hash values are actually matching, which means the email or the message was not changed during transmit, which is keeping the message integrity from tampering around with anyone other than the original owner or the sender. So what the structure of a DKIM record, the public key is as follows. In the name or the host of the record, by the way, you can have two types of DKIM records. One could be a TXT, another could be CNAME. A TXT record is the direct values of the public key, whereas a CNAME is just mapping it to another, let's say, entry and then resolving to an actual the same as a public value would be. It's mapping it to a key, whereas the TXT one is the actual key resolved. So a selector here would be at the start of the record, and as we can see in this example below, we have Google in here. The idea behind having selectors is, first of all, to let the server know which DNS DKIM public key to retrieve. Without it, the DNS zone would have just duplicates of DKIM keys and the server would not know which exact one it's looking for. So in the DKIM signature, the selector is also added. And when the server receives that, it uses that selector to look up in the DNS and decrypt the message. So a selector is very needed, and you cannot have more than one of the same selector name in a single DNS zone. And then the structure comes as that underlying domain key. This is just a protocol. And then at the end of it, the domain is added, which is standard for DNS zones. The values will start with a version, V equals DKIM 1. Again, standard version. K would be the algorithm used for the encryption. And then the P equal values would be the actual public key. This is what's most important. These two tags, the version and the algorithm, are not mandatory to have. What is mandatory for you to have is the public key, which is going to be used to decrypt the DKIM signature. So DKIM verification, I think we went over this, how it works. You send an email, it uses both keys. Just to summarize things, it uses both keys to generate a unique hash value and add it in the email header. When the email is received, it will decrypt it, make sure the values didn't change. And the reason for that is because DKIM is using elements in the header. It's using those elements to encrypt the email. And if any of those elements are changed, then the hash values would be changed. So the email would fail DKIM in that case. But if it's not, it will pass, and the email would be essentially would pass DKIM. Okay, so just to conclude things so far, SPF is a protocol that you use to define which IP addresses you're allowing to send out emails from your domain. DKIM is the protocol that you used to maintain message or email integrity by using an asymmetric cryptography to sign emails, encrypt them and decrypt them and compare values. But the important thing to notice here is while both of these protocols are very good to have to authenticate and make sure the integrity of your email is not changing or is not compromised, they do not actually protect you from outside spoofers because they still, the dots do not connect to maintain or make sure the from address is not spoofed. And that's where DMARC comes in. So let's talk about DMARC a little bit. DMARC stands for domain-based message. And the three more important part of this is authentication, reporting, and conformance. So authentication, this is where DMARC connects the dots between the SPF and DKIM protocol and adds alignment. It works upon SPF and DKIM. It's not reinventing the wheel. It works with them by using their authentication, plus adding an alignment process where it's making sure that the from address and, let's say, the DKIM domain address, or the from address and the SPF address, which is the return path, are the same. They are aligned. So we'll go through those in a second, but that is the main idea behind it. That's for the authentication. Reporting is a very, very good thing that DMARC also has, is it provides two separate options for reports, one of them being the aggregate reports, another one failure reports. And both of them are different. They work separately, and they help an admin see all their outbound communications, email communications, even if it's not sent internally, even if it's spoofing emails, phishing emails, they would get to see those examples and the aggregate reports or the failure reports. And then lastly, the conformance part is DMARC has policies that you can enforce. It has 3 policies. First one is just monitoring, which is just not doing anything, collecting reports, letting the admin go through them and get everything configured properly, get everything set up for enforcement. Second policy is, and let's actually switch this. So it's going to be quarantine. And then the third one is reject. We'll be talking about those here shortly. Let's just cover the basics of DMARC. So it works upon SPF and DKIM, like I mentioned. What it adds is for DKIM, in the DKIM signature, there is the domain tag, which is this one right here. So it compares this domain values with the from address values. That's what alignment for DKIM is doing. And then for SPF is just comparing the from address domain with the return path address domain. The idea behind this, how it secures the originating side of the email, is even if the attacker would modify these too, which is possible, it's not going to pass authentication just because you need DNS records, and the admin will not go ahead and safe list the attacker's IP or create a DKIM signature public key for the attacker. So it's redirecting the authentication into the DNS by doing this. And if it's not actually a legitimate source side of sending email, it's not going to get authenticated. So DMARC is another TXT record. This is what it's going to look like. It's also going to have a version here, a policy, and then RUA roof tags. These are the reporting tags where the reports will be sent to. And you can only have one record for DMARC. It's better if you have it on a domain level because the subdomains will inherit it from the parent domain. So these are the policies that we've talked about. None will not do anything. We'll just let the reports get collected for you to analyze and make sure the configurations are correct. Quarantine is where you would say to quarantine emails in the spam box of the recipients if they are failing DMARC. And reject is the same thing for failed emails that are failing DMARC. It's going to reject them and send it back to the sender with a bounce back error. So we went through the alignment already. We can skip this part. Let's take a look into DMARC aggregate reports. This is the file format that they come in, which is XML. As you can imagine, this is pretty hard to read. For me, it's doable. For anyone else, I'm not sure. But what our platform does in this case is we have algorithms that we run through these XML reports, and we have a database of ESPs, platforms that are used to send out email. We have a very large one, so most of them will be picked up like these ones, plus Google Workspace, alongside with more than 1,000 of them. And we have guides and again, we run the algorithm first. We make sure that they are set up with everything that is necessary. If they are not, we have configuration guides and the process. We have everything with the blogs on how to get things configured properly to make sure you don't run into any incidents when you enforce DMARC. In conclusion, SPF and DKIM alone would not protect you from email spoofing attacks. DMARC, what adds is alignment with the authentication, reporting with the aggregate and the failure reports, and then conformance with the policy enforcements. You can't reach SPF. Well, yes. So in some cases, I would also like to talk about best practices. I'm almost done here. So best practices in the industry is from the ESP side of things. They would have to support their customers in these configurations. They would have to give the customers ability to configure a return path address. Some platforms up there, even nowadays with Google and Yahoo requirements changing, they do not do that. They have to simplify the configuration for DKIM, for example. And from your side, you would also have to make sure you deploy DMARC, you make sure the SPFs and DKIMs are configured for all of your email sending platforms. Make sure you actually reach an enforced policy of DMARC, not just leave the project without enforcing and securing things down. And then lastly, what I would really recommend is locking down all parked domains or lookalike domains that you have from spoofing attacks as well with the DMARC reject policy and nothing to configure because those are parked domains. You don't have any configurations to do. You just add a DMARC record with the reject policy and you should be set up. That's it. Any questions? Anything?
Thank you very much, Joseph, for this excellent introduction. At points it was very technical, but you also very much grabbed, and also on the previous slide, your conclusions, why it's so important to work on your email security and what measures you can take. Now, people haven't gotten in trouble with their email yet. Please note it may happen in the future, so work ahead and think of what you can do. If working around the world, you see which policies or which standards are best adopted, then it struck me that in particular in Australia, this DMARC, DKIM, SPF is on a very high level of adoption. And why is that? Because a couple of years ago, there was a problem. Addresses were heavily spoofed. Campaigns were done with alleged email addresses of politicians. And this led to a countrywide movement towards adoption of these standards. Now, of course, you can wait for these things to happen, but you can also preempt that. And in the Netherlands now, for instance, these standards are also obligatory for government services in a government policy that says, please apply or explain why you can't. Maybe a consideration. I don't see hands for specific questions. I do. Please, one question coming up. Please introduce yourself and look forward to your question.
Hi, good morning. Kirk Sukram here from Trinidad and Tobago. I have a question in terms of the use of DMARC. Are there any challenges with the implementation of DMARC by IT experts?
Yes, that's a very good question. Usually with DMARC, with the setup and enforcement, those are the easy points of DMARC. Configuration, it all depends on your infrastructure. If we're talking about, let's say, a couple of platforms and they do actually support SPF and DKIM configuration, it's actually pretty easy. It might take a week or two to get the reports, digest them, make sure the configurations that you've done are good now. Everything is configured, but with some other ESPs, it could be challenging. So these best practices also applies for ESPs. They should provide options for these configurations and everything for their customers to make everything simple and easy. There's also, from experience, I've worked with big organizations or companies that have a very large infrastructure. So with a global presence, let's say, they're not sure what Japan's department is using in terms of platforms, ESPs. They are sure what the US department is using. Just some examples are just they have to do some homework on that, get a list of everything that is being used. We do see them in the reports, but we need confirmation that they are actually legitimate. We don't want to configure a source, a spoofing attack source as a legitimate source. So there's a lot of things to be done if it's a big or a large infrastructure. If it is not, then it's not complicated. It totally depends on the infrastructure, I would say.
And then we move on. Nigel Casimir, please.
Thank you. Nigel Casimir from the CTU. Well, this is new to me. And let me just say, if I got it correctly, I'm trying to summarize SPF, DKIM, and DMARC based on what I just heard. DMARC, you'll have to explain a little bit more for me because I don't think I got the whole thing. But SPF is a protocol that determines which IPs are allowed to send out emails or which servers are allowed to send out emails. DKIM is an encryption scheme that uses RPKI, public key, private key techniques. And DMARC is a protocol, is an alignment sort of protocol. I didn't get that fully. I'm looking for a short summary of, exactly what it is and what it's used for. But if you could just clarify that for me, please.
So yeah, just to clarify it, what they did is basically instead of
We're not hearing you.
Please unmute. Yes.
Can you hear me now?
You're hearing it
Yes.
now? Yes.
Okay. So yeah, basically what instead of reinventing something new, reinventing the wheel, what they did is decide to use these protocols for the authentication and add alignment to it. So what alignment is since SPF worked independently, they can work independently without actually verifying the from address of an email. DMARC says, well, that SPF is verifying the return path address. Why don't we connect that with the from? And then when it comes to DKIM, why don't we connect the from with the domain that DKIM is signing this encryption for? So to like easily think of this is just saying I have to make sure that the email came from this domain with the alignment process, and then authentication is done, as in configuration was done by the admins for this specific sender. Because if one of them, it's easy when it comes to like spoofing an email, it's easy to sign an email with a DKIM signature, but not align it. And it's also easy to not sign a DKIM, not sign an email with a DKIM signature, but align it. But it's impossible to do both, almost impossible to do both, and have like make a compliant email passing both alignment and the authentication. To give you the bigger picture here is just using both these protocols. DMARC is using both of them for the authentication while adding the alignment process. And also it has reporting like I mentioned and discussed here. And then the most important part of this is policy enforcement. So but it's saying to the server that if my authentications, my requirements are failing for this specific email, I have this admin has a policy set, let's say, to reject. So if it is failing, you have to reject that email. So the server will actually get the email, it will see the authentication results. They're failing. It will look up the DMARC record. It's a reject policy record. It's going to send that email back. It's not going to notify the recipient that this email came and we sent it back or anything like that. It's just going to send it back without notifying it because it's not sure if it's a legitimate email or not.
Okay, thank you.
Thank you for that, and thank you for the extra clarifications. There's much more to say about DMARC, DKIM, SPF, and it's important to really get it. Most importantly, it's to adopt it. I have one last question, but then we really need to move on because there's more important things in this world.
Hey, good morning. So just adding to what the gentleman would have said, I would have implemented DKIM and SPF in an Office 365 environment. And what I think is important is you gotta like specify your safe senders, because many times I would notice like legitimate senders will get quarantined. And if you want to leverage DMARC, well, then basically you got to look at your policies, and most of the time it's going to drop like high traffic that it deems like that are spam. So it's critical that you really look at the policies before you implement the policy which says reject if you're using DMARC. So I've seen it in action in Office 365, and it's very effective when you leverage the SPF with DKIM.
Yes. In my opinion, it is very powerful. It's a very powerful protocol, but you do have to be careful with it. From experience, we have a lot of people that come into us and they're in an incident level when it comes to their outbound email infrastructure, just because they saw that Google and Yahoo now requires DMARC implementation for mass mailers or bulk email senders. And they thought, well, if they're recommending this, it has to be simple to set up. So add a reject record to this and call it a day. But that would, again, cause an incident. So definitely start with none, make sure the configurations are right, and then start enforcing DMARC.
Okay, thank you for that. And thank you for your excellent explanation, Joseph. As we have two more subjects to do, and maybe one of or more of you would like some coffee afterwards, let's move towards the next speaker, Bevel Wooding from ARIN, the American Registry for Names for the Numbers, will explain how routing can be secured. Bevel, please. And please, if you, sorry, we hoped for 20 minutes for each speaker, but with the questions, if you can get it in 15, that'd be brilliant. Don't hear you, Bevel, if you're talking. One of your, yes, we hear you now.
Told the organizers I will be on for the panel section, so you can move on. You got yourself 15 minutes. Enjoy.
I think he said he'll be on for the panel section. So he's giving you the 50 minutes, so you can move on.
Okay, sorry about that. Then I hope that Kevin Swift from LACNIC, do you stand ready for presenting the value and the need for IP version 6?
Hi,
Hey, Kevin.
Martin. Good morning, everyone. I am ready. I can go if there's no problem. All right. Great morning to everyone. As mentioned, my name is Kevin Swift. I'm Head of Public Safety Affairs at LACNIC, one of the two regional internet registries that provide services in the Caribbean. And I would have loved to have been there. I guess some of you who are interacted with me last week would have known that I recently suffered an injury and it's becoming a bit more complicated than I'd like. So unfortunately, I can't be there physically, but I'm definitely following the discussions. So this morning, we are going to address the IPv6 issue, and I'm trying to use a bit of non-technical points as to why this is very important for the Caribbean. So as mentioned, LACNIC is one of the two RIRs providing services in the region, but one of 5 RIRs globally that has this very similar function, which is the management, distribution, and registration of internet numbering resources, for which you have, as you've been hearing all day, IPv4 and IPv6. There's another internet numbering resource called ASNs, Autonomous System Numbers, that we also manage. And we maintain a public registry of these numbers. So yesterday when Martin was speaking, he was speaking about John Postel and a notebook that would have been the predecessor to what we now come to see as the RIR system. So right now, our members are more than 12,000 in the region. And that would include most or nearly all of the operators across Latin America and the Caribbean. And when I say all operators, we have within the last 5 or 6 years, 2 membership categories known as nano and micro. So even the smallest players can be direct members from us. We also have companies, universities, banks, basically any organization that wants to configure its own direct connection to the internet, they come to us. So what is IPv6? And thanks to Nicolas, who explained a bit earlier these internet protocols. So IPv4, which was created in the late 70s and really spread around the early 80s, it has been what we traditionally knew as the main protocol for moving packets along the network. But IPv4 and the context of the internet at that time wasn't this sort of global commercial platform that we know it to be. The internet at that time was really just a military project that was delegated to a group of scientists in the US, and there wasn't this understanding that it would have had this global impact. So fast forward to the 90s, we have IPv6. And at the same time, you have had this massive commercialization of the internet. It's reaching globally. IPv6 is a new protocol. It offers the possibility of connecting every device, both current and future, directly to the internet. And just for you to have an analogy as to the differences between IPv4 and IPv6, this just gives you an idea of the quantity of IPs. So if all of the IPs in IPv4, which are 4.2 billion, could fit within a golf ball, IPv6 could fit within the size of the sun. So nowhere, not now in our foreseeable future, we will be running out of this IPv6 protocol. Unfortunately, in coming up with IPv6, it was not backwards compatible. So we are in a period where we have 2 protocols being deployed at the same time, and there are these translation mechanisms managing the 2 protocols. But we are moving towards a world that will be IPv6 only, and of the internet's 90,000 plus networks, the IPv6 only group or cluster is something that is eventually growing and expanding, which would mean that for us who are not deploying IPv6, we eventually be locked out of parts of the internet. So let me get into the nitty-gritty as to why all of this is important. IPv6, and I have these 3 arguments I want to leave with you. It's needed for us to connect people. It's needed for us to continue connecting devices, especially when we think about the Internet of Things or Industry 4.0. And it's needed as well as a tool, among other tools, when we come to the security of the Internet. So I always like to start with people because people are important. People are at the heart of everything we do. So over the years, as LACNIC, we have allocated about 188 million IPv4 addresses which allowed us to have the 400 million internet users that you're seeing here today. This is a rough estimate of the population of Latin America and the Caribbean. So 400 connected within Latin America and the Caribbean, 188 that stand to be connected. And we have no more IPv4s left. No more IPv4s left. So what does that mean? That means that us as registries, ARIN or LACNIC, we are no longer distributing this under the regular policies as we used to before. You can possibly acquire IPv4, but it's a scarce resource on a secondary market that the registries have no control over. And the value of that resource, it's very, I would say it's volatile in a sense. I mean, it has been stabilizing, but the registries have no control over the value of what people would charge for you to acquire IPv4 resource. So IPv6 is just needed for all of the talks we've been having yesterday. We touched upon digital divide. So according to the World Bank, the Caribbean's total internet penetration is about 79%. So there's still 21% of people that still just need to be connected to the internet. And if we were to take this a step further, we talk about meaningful connectivity, and meaningful connectivity would include parameters such as high availability, regular use, quality of service, security, trustworthiness, affordability, and access by appropriate devices. Now, this is a hybrid concept of meaningful connectivity based on UNE-CLAC, ITU, Broadband Commission, and other definitions. We need more IPv6 for this to work. We'll be very much stuck and stagnated if we were to just rely on IPv4. Moving along. So as a strategic consideration, the device component, we need IPv6 when we think about the growth of interconnected devices. That is far more exponential than the increase of just users. So think of everything from Internet of Things, smart cities, smart homes. In the past, you used to look at technology to human as a one-to-one mapping. Right now, the average person has at least 2 to 3 screens by default, and then we haven't even gotten into wearable devices and the like and the smart homes. So we need IPv6 when we think about the devices that need to be connected. And the security component. Now, IPv6 is not a magic bullet, but it does allow for traceability and for us to go back to the initial engineering principle of the internet, which was end-to-end connections. And let me hit you with a couple of unfortunate facts. Back in April 2012, the website of the Parliament of Trinidad and Tobago was hacked. And even to date, none of the perpetrators were identified because it's almost impossible to track it. So the traceability of transactions and that traceability component, along with other instruments that would treat with data governance, so all that includes data protection, your cybercrime, the practices to be installed between public and private sector, those are needed. But deploying IPv6 is a huge benefit for that traceability and having operators be able to identify and IP address the subscriber. So there's a current practice called CGNAT, which is basically using one IPv4 and splitting it among thousands of end devices and users. That makes it very complicated. It has its implications for quality issues in the future. IPv6 allow operators to do that one-to-one principle where they can actually map a single device to a single IP, and there are many IPs, as I mentioned before. So is this region ready? Let me give you a snapshot as to what obtains in Latin America and the Caribbean. I have here some of the top IPv6 economies within the LAC region. So you would see, for instance, Uruguay is well ahead of the game with 52.4% IPv6 deployment. So what that means is that 52.4% of its internet traffic has IPv6 capability to the end user. You have as well Brazil and Mexico, 49% are close by. And as you go along, you'll see that these differences. So Chile is a bit behind. Let's go directly to the Caribbean. And this chart tells us exactly where we are. I did a couple of things here. I let us see what the exact size of the Caribbean membership is, which is 269 members. But at the same time, I am indicating here what the deployment rates across the Caribbean are. So I would say, thankfully in Guyana, we're at 21.3%. And if I'm not mistaken, there are just about 1 or 2 ASNs that are responsible for that. So kudos to you if you're in the room. Trinidad and Tobago with 25.9%. Now, Trinidad and Tobago has been a top IPv6 economy for quite a number of years. Suriname at 25.3%, St. Martin 22%. And then we start to go down past that. So for instance, and I'm not name and shaming anyone here, but we have Belize with 24 members only deploying 5% of its traffic with IPv6. Curacao with 20 members and it's only 4.1% of their traffic, it's IPv6 ready. And you see the figures go down till we have Cuba with 0.2%. French Guyana is an interesting case because French Guyana at some point in time, if you look at its trajectory, it was deploying IPv6 in a huge fashion. I believe there was just about 1 ASN that was responsible for a huge size or share of French Guyana's traffic. And then a decision was made to stop deploying IPv6. So that's why they're now at 0. And the interesting fact is that the grand majority of members here, 99.5% of Caribbean members, have IPv6 already available to them. And why is that? In 2012 at LACNIC, we came up with a policy that said that if you're requesting IPv4 resources, you had to make automatically a request for IPv6 resources, and these resources would be afforded to you at no additional cost. So what we really see here is that there's a disparity in the technical knowledge and the benefits towards deploying IPv6. So that's one of the things that LACNIC has been working on over the last couple of years, is just ramping up the instances where, 1, we could raise awareness on the one hand as to why this is important, and 2, go to the crux of the matter and work with technical folks to actually build capacity in deploying IPv6 and all of the translation mechanisms required in between. So here are some best practices, and these best practices, they are aligned to several stakeholder groups. So everyone has a part to play in this. IPv6 deployment is best, or it's more successful when you take a multi-stakeholder approach. Firstly, when we think of governments, we know governments are in the business of regulating and lawmaking. In this case, regulating IPv6 use is not efficient because you can thwart somewhat the market dynamics in your country if you were to take a hard and strong approach about saying everyone needed to deploy IPv6. However, you can look at it from a more collaborative perspective and incentivize IPv6 adoption through government's infrastructure. So for instance, if government is looking at the tendering process to deploy certain services or infrastructure, it can require that IPv6 is part of that solution, and therefore those in the market willing to provide that would make the requisite decisions to have IPv6 available. Let me just skip ahead in the interest of time. So this is a bit of what I was mentioning before in terms of what governments can do. They can also, within government networks, request that operators retain or use that ability to map an IP for...
That's right, and we still have 2 speakers.
Hello? Okay, sorry. To map an IP for each of its identifiable subscribers. And at the same time, that NATing issue that I spoke about, CGNAT, where you're splitting IPv4 among thousands, to actually limit the use of that while you encourage IPv6 to be deployed. And as I mentioned before, when it comes to the government's procurement practices and IT purchases, using IPv6 or having it as a requirement is a huge incentive for the market. There is a huge concern of e-waste and of technological dumping by having obsolete equipment come into the region. And this is not a far-fetched story. Within Latin America and the Caribbean, there was a huge government administrator that acquired a lot of equipment at a steal of a deal, too good to be true, only to find out that those equipment were actually just IPv4 only and not IPv6 capable. So you have to limit as best as possible, working with your border control, the imports of IPv4 equipment. So that will work for both government as a stakeholder and also for the market at large. If you were to introduce that at a level of customs and duties, you can see that you can already push or encourage a community to be more IPv6 ready. And this is my last point for government. Governments, especially in all of its activities dealing with digital transformation, should require at least one of its services to be IPv6 compatible and publish government websites and content via IPv6. So I'm moving along in the interest of time, and you will have the presentations after. This is a summary of some of those actions that we just mentioned, and you get an idea as to where exactly would be the intervention point along concessions or in terms of government policy, public policy, and the like. And operators, if there are operators in the room, I'll touch on this quickly. IPv6, so the IPv4 issue, this gives us an idea as to what's the cost of this IPv4, which is not anymore in the hands of the RIRs. One of the things the RIRs have to do is to register whoever is going to use an IPv4. So if there's someone selling IPv4 from one of the 4 RIR regions where you can sell IPv4s in and out, the registry is required and they charge an administrative fee to update the record and say whoever is now using this IPv4 that this is what the whois would show of that. But the IPv4 right now, it's going at a rate of about 50 US per IP. So if you're running any sort of operation, you can easily imagine, and this would be very costly, especially if you're using the older or traditional ways of dealing or developing, addressing plans and designing networks. IPv4 is really not cost effective whatsoever. So these are just some of the current trends. IPv6 will be visible in most networks, but it is visible to a certain extent. We saw the exceptions at the Caribbean map, and those who are deploying IPv6 will tend to stand out more than those who are just deploying IPv4. That's something that's going to be perceived at the level of customers, and effective deployment takes no less than 4 years now already. When you're looking at customer premise equipment and they're already IPv6 capable, but for us, a successful deployment looks at what happens from the customer side straight back to the core of the network, being able to do an effective deployment without any sort of huge upsets to your financial planning. You're looking at a period. It's not going to be done in one go. You need to phase and strategize on how you're going to deploy that. And this is just another point about, I'm going to go to this. Low latency. So selected sites load 5% faster in median and 15% faster in the 95% percentile on IPv6 compared to IPv4. So there is a performance difference right there. IPv6 now is faster than IPv4 when visiting 20% of top websites. And it performs better than IPv4 for mobile networks. In terms of the content that people access, most of the global content delivery networks, they are already deploying IPv4 and IPv6. I'm going to move along in the interest of time. I'm going to touch now on academia. So why is academia, what are they expected? Why are they involved in all of this?
Indeed, make it quick. Sorry, Kevin.
Sure, no
Time
problem.
flies.
All right, so I'm about 2 slides again. So when we think about research, innovation, capacity building, academia plays a fundamental role. So we're not thinking of academia just as a user of IPs and all of the bring your own device policies and the like, but we're talking about academia in that cross-section along with industry to come up with innovative next generation content and having all of that based, not just content, but content and applications and systems, and having all of that based on IPv6. So there's a huge role there for academia to seize. And last but not least, the end users, of course, very important in terms of being part of the solutions. Well, firstly, when you think about home security solutions, IPv6 would be very interesting or more useful to end users. If they're doing gaming, if they're doing things like wearable devices. And then here you have a snapshot of all of the other benefits that you can see towards end users. So with that, IPv6 is not just a technical word or just about technological or technical arguments. It's really about being strategic and avoiding being cut off or being left behind in what is the future of the internet. It requires multi-stakeholder engagement. And of course, one of the things that we as LACNIC, we try to do in this endeavor is to raise awareness. And then we have specific capacity building. You can come to a LACNIC event, which we do twice a year in May and in October. The next event will be from the 7th of October to the 11th in Asunción, Paraguay. So feel free to come to the event. And you can also look online where we have a number of online campuses, LACNIC Campus, and there we have basic and advanced IPv6 courses that you're free to peruse. Well, the basic IPv6 course is free. The IPv6 advanced course isn't so free, but it is a useful tool in getting a great understanding. I'll just leave this with you for all of 10 seconds or as long as Martin allows me to. So you can take a snap of this QR and you'll be able to find more resources on IPv6 and deploying it effectively. So with that, I'd like to stop sharing and hand back over to you, Martin.
Well, thank you very much, Kevin. That was a very clear presentation. Also on the necessity of IP version 6. For your reference, IP version 4 addresses is 4.2 billion, that little cent drop that he max. And we are double that much people in the world. So only that wouldn't have worked already. IP version 6 is really a necessity for further growth for new users and the speed that we see increased. There's examples of these policies, practices in other countries. Again, kind of comply or explain policy in your country may be a very good complement. And I look forward to have some of these tables that Kevin just presented also back in the workshop report to extra underline the points of effective need of that. So with that, last but not least, routing security. Bethel, sorry for asking for you earlier, but that's because of an hour time confusion between us. Right now, you are ready to provide a short introduction on routing security, after which we really will postpone the wider and deeper discussion about, so what do we do about it, to block 3 later today. Please, Bethel. Okay. Bethel, we don't hear you. In which case, maybe best is now to take our break and check in with Bethel, please.
So sorry, is there room for one question that I had for Nicholas before we go to break?
For the IPv6?
Well, no, on Nicholas's presentation, because we didn't take questions then. DNSSEC.
For DNSSEC?
Yeah, for Nicholas, if he's still around.
What is your question on DNSSEC? And then we have one more in the back of the room.
Okay, well, let's go to someone, one of the participants first.
Okay, please, sir.
Yeah, IPv6 is actually being used in Guyana. Most of the ISPs have IPv6. Most of the major platforms such as Google, Facebook, and Netflix, they have IPv6 enabled locally that they're doing peering with. So we are using IPv6. It's just a matter for the websites them, like the local websites them, whichever hosting partner they're using for them to implement IPv6. But IPv6 is being used for like Google, Facebook, Netflix. They have IPv6 enabled locally in Guyana. And the major partners such as GTT, NDMA, and UG, they also have IPv6.
I guess that's correct. You have IPv6 enablement on different parts in the network. And at ISP level, the preparedness is pretty big, right, Kevin?
Yes, in the case of Guyana, and I've been tracking Guyana for quite some time, it was really during the pandemic, and I think the pandemic has its benefits in that sense, that Guyana really turned on its IPv6 traffic. So you're quite right, there are a number of ASNs are attributed to Guyana's IPv6 traffic, and as you've accurately identified, it's not really a question of the local websites to start publishing their content via IPv6, because the content that Guyana will be accessing via the international ones, your Google, Akamai, and the like, yes, most of those CDNs, if not all, are already deploying their content in both V4 and V6. There's a protocol called Happy Eyeballs, which would mean that your equipment would prefer to run via V6 than V4. So Guyana, kudos to you, because as I said, before the pandemic, it was at 0. And the pandemic provided a perfect storm, and Guyana and neighboring Suriname were two of the countries that during the pandemic had this sort of astronomical jump in its V6 deployment and usage.
Thank you very much. Albert.
Yes, Albert Daniels, I can. Nicholas spoke about the international standard DNSSEC and how it can provide a layer of security during that time that the domain name gets translated into the IP address, so that, you know, persons' banking details and so on don't get exposed. What I wanted to ask Nicholas for the information of the participants is, who needs to get involved in making sure that this standard actually is deployed effectively? Does the end user have to do anything? Does the ISP have to do anything? What is ICANN's role? What about the person building the website, hosting the website? Can you tell us a little bit about who actually needs to get involved so that we get advantage of using the benefits of utilizing the benefits of DNSSEC?
And Nicholas, if you allow me to bridge it to RPKI ROA as well a little bit, because Bevel hasn't been able to contribute. RPKI and ROA are the standards relating to the routing security for the numbers, and DNS security and routing security go back to back. Nicholas, please.
Yeah, thanks, Martin. I will try to summarize very fast both of it and the question. The question on who needs to get involved, it's end user. No, in the case of DNSSEC, up to this point, up to this moment, the end user has no task to do, no specific task to do, because DNSSEC, as I mentioned, acts between the dialogue between the recursive server, which is the one that searches for the information, and the authoritative server. So the ones that had to do tasks are the ones that administer either a recursive server or an authoritative server. If you are an administrator of an authoritative server of DNS, you have to sign your zone. You have to sign every information that you store on your authoritative server in order to provide the information when a recursive server asks for it, and provide a digital signature for the resolver to be able to verify. And if you operate a resolver, if you operate a recursive server, you need to enable what we call DNSSEC validation at the resolver level. To enable DNSSEC validation at the resolver level, which is it's a very simple, very simple task. It does not need. It does not mean that you will have an increased amount of operational weight or whatever. So normally ISPs operate. Some of ISPs or most ISPs operate to some degree a recursive server to provide their customers with a resolver for DNS resolution. So those ISPs running or operating a recursive server will have to enable DNSSEC validation. And those running an authoritative server will have to sign their own. Let me show you something in order to also answer Martin request. Let me share you this. This is a map made. I'm not sure if you are seeing this in the screen. Is this on screen, Martin? I'm not sure if you are seeing the map. Okay, so this is a map about all the RFCs. So this is all IETF standards related to DNS, and I will zoom out here because this has always been amazing for me, right? All of these that are listed here are the standards related to DNS, and the links between them is the relationship between them, how they relate to. So as you can see, there are over 100, far over 100 standards that are related to the DNS. So what can I do if I want to know about DNS and all the other protocols related to it, like DNSSEC, other protocols that are privacy, etc., etc. It's almost impossible for a technician to go through all of these standards in order to get the whole picture of the whole DNS standards ecosystem. So there are programs that are developed by different organizations that help. The scope of the program, the aim of the programs is to help the people that operates, in this case, DNS servers, in order for make it easy for you to know what are the best practices that you should be deploying in your servers, etc., etc. In this case, I can launch it a couple of years ago, a program called Kindness, which is the aim of the program, the goal of the program is to provide people that operates any type of DNS server with a central or a repository with all the best practices related to DNS. So if you operate a resolver, you come here and you will have a lot of resources on which are the best practices that you should be deploying in your server. There are examples of configuration, how to actually configure those features in most used DNS server software, etc., etc. You have a self-assessment you can perform in order for, and it will make you from 5 to 7 questions that you have to click all of those features that you are already implementing, and it will give you a sense of where you are standing in terms of standards implementation and good practices implementation related to DNS.
And we'll dive deeper into Kindness after the break as well.
And as you mentioned, Martin, there's also a kind of this Kindness program was kind of let's say copied, or it's the small child of another program that takes care of best practices applied to routing, and that is the manners program. So if you have an operational team that leads with all the routing stuff and the network configuration, etc., and you need to know about the best practices around routing, you can go and look for the manners program, which is the same idea, but instead of applying to best practices to the DNS operation, it's best practices applied to routing operations. So I think those two programs are a key resource to any technician whether they are operating a network or any kind of DNS server.
Thank you very much, Nicholas. And with that, and also being aware that the speakers for the next hour are ready, I would still invoke a coffee break that you deserved so well. But let's keep the coffee break to 10 minutes, please. So let's make sure that you're back at 7 past. So 10 past we can start. And I hope that works for our speakers online. I saw Dan already and others. So please enjoy your coffee. And thank you to the speakers for the excellent contributions. Great if you're very welcome to stay, but also to join us at the slot where we talk about action planning following this, which will start at 15:45 local time. So that's the same time as Washington, D.C. for those who are aware. Okay, be back in 10 minutes. Thank you.
Martin, can I, while we're here, can I just do a test of screen sharing?
had an awesome coffee break. For those who are joining us online, I'm sure that you did too as well. We can all agree that the first panel discussion was extremely informative. We learned a lot. I can say from my end as well as a Guyanese speaking, I did not know a lot of these things were happening, and we can also see room for improvement, of course. I usually like to begin with a joke before we head over to the discussion. I believe that's true, and many of you did enjoy your coffee break. So I have a question here. Why did the internet governance expert switch to decaf? I'll repeat that question again. Why did the internet governance expert switch to decaf? I'm seeing some faces thinking, wondering. All right, he switched to decaf because he was tired of dealing with too many Java scripts. Ladies and gentlemen, welcome back to the second session of day 2. I'll hand the mic over to the experts as we begin the discussion.
There's something green now, so thank you for that. And I must not be an internet governance expert because I'm still drinking my coffee caffeinated, and I need it. But not because of the discussions. I really appreciated the introductions this morning. The level of variety. You need to touch upon a little bit of the technology to understand what you need to do on the policy level, and I think that was very well bridged by the speakers we had earlier. At the end of the day, and please keep note of that, what of this inspires you to action here? So the next block is about inspiration, and before lunch, I'm very happy to introduce some speakers on global best practice, global tools that can help prepare for steps that can help understand what the situation actually is. And leading in that is Internet Society. Internet Society, I dare say, exists longer than I can, and has been fundamental in making the internet grow in a multi-stakeholder way from very early years. We have Dan York online, and here in the room with us is Nancy Quiros, who will introduce the next session, which is really on understanding better where we are.
Thank you. Also, together with me is Dan York, our technology director, and today we will be speaking about the Internet Resilience Index and an initiative that we started at Internet Society on how to measure the health of Internet. Dan, can you please share your screen?
Yeah, I think I'm shared. And good morning or good afternoon to you all. I am coming at you from just north of you, well, a lot north of you up in Vermont in the United States. So greetings to you all.
Thank you, Dan. Okay, so let's start by understanding what is Pulse. So I will ask you a question. What would happen if I ask you right now to provide me with the indicators of health of the internet of your country? What would happen? Probably the first question that you will have is, how do you define the health of the internet, right? And once you figure out that information, probably you will think about some indicators that you can look for. And once you look for those indicators, probably you will get a lot of information from the web. Information that probably you can trust or not, because it is difficult sometimes to know if the information that you're getting from the web is a trusted information. So basically, this is what Pulse comes to answer. Basically, we put together all the information that is already in the web in one single place so that anyone can access it in a way that can be useful. The Pulse initiative was launched on December 2020, and as I said, we curate internet measurement data from trusted sources to help everyone gain deeper, data-driven, and insight into the internet. Something important to highlight here is that we do not produce the information or the indicators, but we pull that information into one single place. What are the benefits of Pulse? First, it helps to assess whether efforts to ensure that the internet remains open, globally connected, secure, and trustworthy are working. And second, it allows policymakers, researchers, journalists, network operators, civil society groups, and others to better understand the health, availability, and evolution of the internet. So here is an invite. Please explore our webpage. Here is the link, pulse.internetsociety.org, so that you can understand what we are talking about. Next slide, please, then. Okay, so here you will find all our data partners who help us extract all of the information that they already have into our Pulse webpage. And now we will talk about the health of the internet and how we figure out the way and the methodology to measure the health of internet. How do we track the health of internet? Basically, Pulse tracks the health and the resiliency of the internet by curating the data in several areas. The first one is the implementation of enabling technologies, then the concentration of services on the internet, and then in order to pool and calculate the Internet Resiliency Index and country reports, we use about 30 individual metrics. Also, we have the Internet Exchange Point Tracker, which tracks the key data about IXPs. And in coming, in this year and coming years, we are working on Pulse 50/50, which is a tool that will track the proportion of the traffic staying local. And also we will be working on historical data, and we will improve the usability of the tool.
So to talk a little bit about the enabling technologies that are here, this is part of what we just heard in the previous session for those who were listening around IPv6 and DNSSEC and TLS 1.3, just other elements that are there. This section tracks those technologies, shows the deployment. So if you want to see where is IPv6 deployed, and this is our aggregation and display of these metrics that are part of that there. We also have a whole section on concentration, specifically looking at what are the, how many transit providers are there, how many different, data centers, what's the market look like in that space. So both of these are useful tools to understand what is the health of the larger ecosystem of the internet in that environment. So the IRI, or the Internet Resilience Index, that we'll talk about, and you can see right there, it's pulse.internetsociety.org/resilience. This is what Nancy just referenced, that has about 30 different sets of public data. And we put it into 4 different pillars. Infrastructure, you can see what's the physical infrastructure, how much is there, what kind of connectivity is coming out of the country. Performance, how quickly and what does it work. The security elements, and in the market readiness, what's available in there. These are the 4 different kinds of pillars of what we talk about. We do have a very detailed methodology. If you go to the website and look for that, you can see a link there. It is very detailed for those who want to understand the scientific, the background around what we are presenting and in the way that we're doing it. The infrastructure, just to show you a little bit, it talks about what kind of coverage is available? How is spectrum allocated? How many people can actually reach fiber connectivity? What IXPs, internet exchange points, which help make a more resilient connected mesh? What's the level of data center deployment within a country? And because of the location of the event, we pulled up information from Guyana that you can go and see right here. And we can say, well, in the scale of things, it has kind of a lower indicator around cable ecosystems, mobile connectivity, coverage. Those are some issues that you can see right inside of here. You all can go to this site, take a look. You can, tell us what you think about it, but you can also be able to look for your country or your region, what's there. I will pass it on to you, Nancy, there.
You hear me? There you go. And now we have the performance where we measure the latency, upload, download, and jitter for fixed networks and mobile networks. And here, Dan, can you please help me to share the Guyana report?
Yep, there it is.
There you go. Here you can find what the numbers look like for Guyana. So you can see the score for fixed networks and mobile networks.
Similarly, we have a section around security. And we just heard about DNSSEC as one of the areas, and it looks at what's the score related to DNSSEC adoption and to validation. We mentioned earlier about routing security and RPKI and ROAs and some of these different pieces that were there, and the manners, the mutually agreed norms for routing security. What's the score in kind of there? How protected are they? And so these are the elements that we put inside of these scores. And again, we have these ratings, and you can see that what we've measured out in Pulse for Guyana. So you can see the enabling technologies, which is IPv6 and some of the security technologies for the web, DNSSEC, manners, DDoS protection. Those pieces are all right in there in different forms. So again, technologies and the health of what we're looking at in here.
And finally, we have the market readiness, where what we do is that we measure the ability of the market to self-regulate and provide affordable prices for end users. Under market readiness, we have two groups. The first one is the market structure, where we have affordability, which is related to the Gini score. Then we have market concentration, which is related to the market share. And finally, we have AS hegemony, which is related to the dominance of the market. Then in the second group, we have traffic localization, where we have peering efficiency, where we have a comparison of autonomous systems that are in the IXP versus autonomous systems in the country. Then we have the domain count, which is a count of domains according to the CCTLD. And finally, we have the e-government development index, which is something we pull from the UN. And here is an example on how this information would look like for Guyana. So we have 30% for market readiness, where we have market structure on 45% and traffic localization on 16%. And now, Dan, can you please share the country report?
Yep, we should have that there now.
There you go. Here is the country report. The country report is divided into three sections. The first section is open internet. So under open internet, you will find indicators on internet use, internet resilience score, transit provided diversity, retail ISP diversity, and popular content locality. And then the second part is globally connected infrastructure. So here you will find indicators on that sense. We will have networks assigned, addresses assigned for IPv6, IPv6 adoption, and addresses assigned for IPv4. And finally, we will have a section for indicators that are related to secure and trustworthy internet, where we will have the naming security status, naming security coverage, naming security adoption, routing security adoption, routing security coverage for IPv4, and routing security coverage for IPv6.
A useful part about these country reports is that you can take a look at the country report for your country, obviously, and look at that. You also can download this. There's a link at the very top that you can go and download a PDF to share it with other people, with policymakers, with journalists, with others that are there. Some of these scores, particularly when we look at the globally connected infrastructure and the open internet, look at how resilient the internet is within this kind of country. How many transit providers are there that are providing access outside the country? How many different retail ISPs are there? What's the pieces that are there? We do realize this is, our curation of all of this data. There are some challenges around it. We pull data from various different public sources. Some countries don't have all of the data because they're not in those sources, or sometimes it's not clear. We've had a couple of cases where people said, well, wait, we have an IXP, an internet exchange point in our country, but it's not listed in the peering DB, where we pull the data from. So if you go to a source, and if you go to your country report and you say, wait a minute, we're missing this or something, let us know. We can help you indicate where this is being pulled from and what's going on. One of the other challenges, and this is something we're seeing around the area, I know it's also a challenge in the Caribbean too, is sometimes getting in-country measurements. One of the things we're always looking for is how can we help expand some of the existing measurement collection systems and some of the other different systems that are bringing in data. Because without that in-country measurement, sometimes it's very difficult to be able to go and ensure that we're getting them. So there are these challenges, but this is a benchmark. This is a tool that we're using that we hope has been useful already to many people in looking at what are the resilience levels of different countries versus other countries. How can we help? Where are the points that need improvement? What can be done to help make a country more resilient in times when we need that? As part of that, one other recent tool that we've released is something called the IXP Tracker, which if you go to that part of our website from the thing, you can see how many active internet exchange points are there within the country. What's going on there, what's been the growth. Also, how many of the local networks are actually interconnecting at the internet exchange point, which gives a sense of the resilience, again, of the internet within that particular country. So these are all tools, things that we have developed at the Internet Society to help you all in understanding the health of the internet in your countries. So this is what we've provided through Pulse.
Okay, so as I was saying yesterday, it is important to take action, and sometimes the smallest actions will be very impactful. Here are some ideas on the things that you can do to help us promote this tool and to share this tool with people that can find that this data useful. You can check on your Internet Resilience Index and your country report. And then you can share it with technical community, policy makers, journalists, and decision makers. As Dan was saying, we have the report in PDF, and it is very easy to share and to analyze it. And as a way to help you with this first step, I brought some prizes. So here is the deal. If you share anything that you like from today's presentation in your social media with the hashtag Pulse, you will be allowed to grab one item from the table that is in front as a gift for your first step in this process, okay? And we will do this at lunch just to keep the order of the room, but please, 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 try your first step. I am helping you. I hope you all will grab something from there.
And with that, I will say you can also go, and as you can see here, we have other ways to engage with us. You can take a look and you can subscribe to our newsletter. You can also dive in deep, if you'd like to that Pulse IRI methodology that I mentioned earlier. And if you have questions about this, if you have comments, feedback, things you'd like to understand more, please, we're very open to feedback. We want this to be a service that is very useful to people across the internet to understand these metrics around the larger health of it. Please, you can email to us at pulse@isoc.org. We also have an ongoing blog there where we talk about these different kinds of issues. We have a whole other section of the site talking about shutdowns, and we spend a lot of time around that. We are also often looking for guest authors. If you'd like to write something around sort of the resilience in your region or pieces like that, we're always interested to talk to people about possibilities for that. So with that, we will wrap up our part and say thank you very much. We are open to questions. We can also stay around later for the session when we get into the action plan as well.
Thank you very much, Dan and Nancy, and thank you for bringing even more than the excellent data and insights. There's even goodies there, but they're still there at the lunch if you all play fair and don't sneak off to start getting them. Thank you very much. I was there when these indicator set was beginning to be set up. And at that point, it looked very promising, but there were no data over time, and now you can see trends and you can see these elements. So, and as Dan also said, it's not absolute truth, but it's excellent input to your policy decisions, whether you're a company or a government. On so, what are the issues that we should consider? What are the chances? What are where lay the biggest challenges? So, really appreciate to pull this platform together and presenting it. Any specific questions at this point? Please.
Thank you, Nigel Casimir from the CTU. As we were going through the presentation, the nagging question in the back of my mind, and it was cleared up more towards the end, was what's the source of this data? Right? And I understand that would be a challenge going forward. But is it explain the current source of the data on the site at all, or is it practical to do so? Because I think that would help local agencies reviewing the site to see if they can provide better information, or or even just the average user going through it, they will at least understand where it comes from. So I had a quick look at it. I didn't see where the sources were clearly identified. So I wondered if there was a practical difficulty with identifying that. Thanks.
Thank you. The whole methodology is in a paper in the webpage. So you will find how we calculate and how we put together all the different indicators and how we calculate them.
No, but I was talking about, if I look at a country report, Guyana, for example, right? There is some data, I don't know, number of IXPs or the concentration of the market and performance, infrastructure measurements, and so on. That's the kind of thing I'm asking about. What would be the source of that data in the country reports? Right? So, the source of the raw data that is used to work out all the indices. Is it from, say, the regulator? Is it from the operating companies, academia? And I'm sure that the sources would change per country, right? In some countries, you might have good regulatory reporting, and others not, and you go to other sources. But I'm just suggesting that the source for each country, as you go from country page to country page, that we identify what the source of the raw data is. And because I didn't see it for Guyana, I just went straight to the Guyana page. I didn't see it on that Guyana page. And
so
I wonder if there's any practical difficulty with having the source of the data being clearly identified on the country reports pages.
Sure. If I can, are you all hearing me now? Okay. So we do, as we mentioned earlier, we have about 30 different sources of data that are brought into those different pieces that come in. So on on one level, because we are amalgamating all of these different sources of data into a common display there, it's a little bit challenging to go and show exactly which ones are used for which pieces. But this slide that I'm showing here shows some of the sources that are there. But I will also take that feedback back to our team that is working on the actual web interface around, can we show individual sources that might be country specific? And I don't know. I will ask that question of our team. So thank you for that feedback.
Okay, thank you very much. Thank you, Dan. We'll see you also back diving deeper into, I got one more question for Carol Roach.
Okay.
And then we really move on to the next one, right?
Quick question, just quickly looked at the Bahama zone. Is there like a table, or is it dynamic enough that we can create a table that will compare different regions, the countries within a region? Because I see the ranking there, I see the percentage, but is there somewhere that I can go on the site and select the region and then see for each indice?
Not at the current time, but we are looking at that. And we are looking at how we can have regions, sub-regions, and that kind of thing. If you want to drop a note to the pulse at isoc.org, and just say what you're interested in, that would be useful feedback to us as we look at developing those kind of resources. Some of it is available currently through our API for people who want to use it with other tools. But again, it would be helpful to understand what you're looking for.
Thank you. I see your behind your eyes, your mind is working. How can I use this? How are we going to do this? So really appreciate it. Thank you all very much for this, Dan, Nancy. And now we'll go into the next one, which is about manners. Manners actually also originates from Internet Society, is now managed by the organization called Global Cyber Alliance. And Andrei Robertchevsky, who's been one of the designers, the developers of manners, is with us to talk a little bit more about what it means, how it can help, and why it's so useful to really adopt that when it's appropriate for you. Just pointing out that this also links into specifically the routing security aspects that we touched upon in the earlier session but didn't go deep into, and no doubt Andre will be ready to make the connection for us and with us. So with that, also from the Netherlands, not originally, but living there for a long time, Andrew Robertchevsky.
Thank you, Martin, and hi everyone. Good afternoon and greetings from Amsterdam, the Netherlands. Let me start sharing my slides. Yes, I will be presenting manners. Can you see the slides? Excellent, thank you. So yes, I'll be talking today about the industry-led initiative called Mutually Agreed Norms for Routing Security. It was started 10 years ago, so 10 years young, at the Internet Society, and was supported by the Internet Society for 10 years. At the end of last year, the operations secretariat functions were transferred to Global Cyber Alliance under collaborative agreement between the two organizations. So I also transferred to support manners there at the Global Cyber Alliance. But before we go into manners itself, let me say a few words about the routing system. Internet routing system is big, right? About 76,000 independent networks that work together, that make up this internet, that define how traffic flows. Each network in routing terms is called autonomous system, or IS, and each of them has a unique number. Now, IS is not a really network. It's a constellation of networks, which is operated under single administrative control from routing perspective. For instance, if you think of a broadband access provider, that all home networks, while separate networks, that will be represented by a single IS with single IS number on the internet routing system. Now, if you look to the right, you will see this picture, excellent picture from CADA, where each of the dots on this diagram is an IS, is a single this constellation of networks. And you see how well they all are interconnected. And the more the dot moves to the core, the more customers they have, the bigger the network is. So the question is how these networks, how they coordinate to know how to move traffic from one of the dots to another dot on the internet. To do this, they use a protocol called BGP, or Border Gateway Protocol. And the basic operation is very simple. The networks learn about the networks they can connect, they can reach from other networks. And of course, they know the networks they connect themselves, and they communicate this information with their neighbors. And neighbors take this information, update their sort of roadmap, and pass this to their neighbors. And that information spreads around all the 76,000 networks, each of them building their independent roadmap of the internet. That is how routing works on the internet in a nutshell. And each sort of network, little network, like home network, it is represented by an IP prefix, right? And there are almost 1 million of those prefixes. So there are almost 1 million of smaller networks on the internet that can be reached. And they all communicate using this BGP. So as you can see, BGP it's one of the sort of fundamental pillars of the internet. Operation of the internet really depends on it. Now, but we're not going to talk about the BGP. We're going to talk about routing security. But BGP being a solution and being a pillar of the internet is also part of the problem. And the problem is that when it was designed, simplicity and scalability were one of the most important requirements. It was back in 1989. And it's amazing that those requirements allowed BGP without major modifications to survive and actually support the internet with all its enormous growth. Unfortunately, security was not part of those. And therefore, basically, this operations, the exchange of information between networks was based on trust. There was no built-in mechanism in the protocol that would allow one network to verify if information they receive from another network is correct. If your neighbor tells you that they can provide path to Google, are they lying, or they are indeed sort of on this path and you can send traffic directly to Google through them? So that is a problem because some of the networks may lie. It's not necessarily always intentional. Sometimes it's a configuration mistake. But as you can imagine, it can create havoc on the internet if that distorts this roadmap that each of the networks builds. And this is not just a theoretical thing. Here in this table, I show some of the examples of those incidents, routing incidents that happen on the internet that hit the media headlines that really created big outages on the internet. And also, this table explains some of the types of attacks that can happen. I will not go into detail for the in the interest of time, but you can see one interesting note I would like to make is that because BGP is a fundamental thing, attacking BGP allows an attacker to attack higher level, higher layers of the internet, such as applications or higher level services. And for instance, DNS service is one of them. You can attack BGP and therefore redirect users to a fake DNS server and provide fake destinations, not necessarily directly, but through this sort of level of interaction. And therefore, BGP security is of paramount importance. Now, well, the thing is that those problems routing security are not new. I mean, we knew about them for almost 3 decades, and still we are not very close to the solution. And the question is, why is security hard? Are there no solutions known? Are there no technologies? And the answer is yes, there are technologies, there are tools that allow each of the network to protect against those incidents against creating those incidents. But the problem here is what is called in economy external and negative externalities. And that means that your inaction, the pain from your inaction as a network is felt by others. And the cost of your inaction is paid by others, right? And at the same time, if you create an action, if you protect the internet from the occurring of those attacks, your personal business case is not very strong. Still, security of your network is in the hands of other operators. In social science, this situation is called the collective action problem, where everyone agrees that we are better off if routing system is stable and secure, but individual motivation is different and weak to create this collective action. So realizing this, and 10 years ago, we realized that, and we thought we need to do something. We need to do something that will stimulate adoption of those tools, technologies that we also talking today about to create a more secure and stable routing system. So there are different ways to solve the collection action problem. And in the past, regulation was one of them. Unfortunately, the internet, it doesn't really work effectively because of the global span and dependencies. Even if you regulate in one country, your networks in this country can suffer from incident inflicted from a little network on another continent, and that happened a lot. It also creates fragmented solutions, right? And because if you regulate in one country with certain sort of, requirements and different requirements in another country, that will not work together, right? A more effective approach is creating a norm. And what is a norm? It's a widely accepted behavior. There are no sort of, debate about that. Everyone agrees that is what needs to be done. And that's a best practice, right, in our terms. It doesn't need to be very high, right? It doesn't need to solve the whole problem, but it should provide a common denominator.
Sorry, Andre, one second. There's no signal in the room I see you online, so your presentation works.
Yes.
But if the room technical crew can connect it to the screens.
Martin, do I need to do something or just wait?
You don't need, you're perfect. It's in the room. Yes, it's back on. So please continue. Sorry for that. Now people in the room can follow you better.
No problem. So I was talking about the norm as a more effective solution to this collective action problem, creating widely accepted baseline, which is not too high and not too low, so it can make a difference. And what is important about norms, those behaviors, that they're visible and measurable, right? Other players in the network should be able to see who adheres to those norms and who doesn't. All right. Oh, gosh. So that's where Manus comes in. It's this collaborative approach. It's really was created by the industry. It's led by the industry. It was supported for 10 years by Internet Society, and now it is supported by Global Cyber Alliance. But ultimately, it is based on the community and the community of network operators. Basically, it is based on two pillars. One is the norm, right? This is undisputed minimum security baseline. And this baseline is defined what we call Manus actions. I'll talk about them in a second. And another pillar, very important, which sort of differentiates Manus from just best practices, is the demonstrated commitment by the participants that they follow this norm, they implement those practices. And this commitment is not just self-declaration, it is audited by Manus, and it is measured by the observatory and published on the Manus website. Just to give an example of those actions, the most prominent program that we launched Manus with in 2014 was Network Operators Program, and it consisted of 4 actions, 4 very important things you need to do. And if a lot of operators do this stuff, routing system will become much more secure. So the first and foremost action is filtering. What we talked about this trust in what you receive from your neighbor shouldn't be there, right? You should verify and somehow validate that the announcements that you receive from your neighbor are correct. And unfortunately, as I said, BGP doesn't have built-in information, so you have to retreat to other outside, out-of-band databases. They're called Internet Routing Registries and RPKI system to validate this information. Now, the trick is, of course, that it also depends how those databases are kept and maintained. And this is where Action 4, I'm jumping to another side of the action spectrum, plays a role where it asks all operators to maintain this information so others can verify and validate. Another two important actions is anti-spoofing. I will not talk a lot about this. If you're interested, you can read about this on the MANAS website, but action 3 is coordination. And coordination is extremely important, not only in preventing, but also mitigating incidents. It's very important that one operator can reach to another operator across the globe and be able to ask for help to prevent some announcements from propagating, for instance. So that was a network operators program that we launched in 2014, but different entities in the internet routing system, they play different role and they can contribute slightly differently to the security of the routing system. For instance, internet exchange points that provide neutral place for other networks to peer, interconnect, and exchange traffic, they can play a very important role by securing this peering environment, right? So Internet exchange point, it also has filtering action in place, but it has a slightly different meaning. It means that the Internet exchange point filters incorrect routing announcement it received from the members and doesn't propagate those announcements to others. In 2020, we launched the program for content delivery networks and cloud providers. And of course, everyone wants to pair with those networks. And we want to leverage this peering power to incentivize other networks to adhere to MANAS. And finally, you can't implement MANAS, you can implement routing security if your equipment doesn't support necessary features. So we launched the network equipment vendor program, and 6 very important vendors are part of this program that demonstrate that using this equipment, you are safe to implement MANAS. Well, this is a summary. As I said, actions are similar in somewhat, but they're different because of different roles of participating entities, but they roughly fall in these 6 main categories. Now, let me talk about the community. I mentioned that that's another pillar, right? The network operators that demonstrate their commitment by implementing those actions and allowing them to be measured. So the community is growing. Well, we have more than 1,100 participants in MANAS. We started 10 years ago, and steady growth. You can see that as we launched new programs, new types of participants joined this initiative. So that's a sort of positive graph. It's a global effort. And here by the size of this dot, you can see how many networks participate in MANAS. So you can see almost, well, on every continent, probably except Antarctica, MANAS is present. Again, I mentioned about measuring, and commitment and transparency is very important for this effort. And for this, we develop a tool which is called MANAS Observatory. Basically, it does provide a state of routing security. It measures compliance, conformance of different networks to MANAS actions, MANAS requirements. But by measuring this, it also demonstrates the state of routing security. Because if everyone is conformant, routing system is more secure. When we developed this tool, the requirements were that the system should be transparent and use publicly available data. So basically, you theoretically could recalculate those metrics, and therefore that should increase trust in the data that we are displaying in the observatory. It should be passive, so it should require minimum coordination from all the networks. And that allows us to measure menace conformance not only of menace participants, but also from all 76,000 networks operating in the internet routing system. And it's evolving, right? Menace community is an active community, and they might decide, okay, well, we probably need to measure RPKI. Oh, we probably need to measure the level of route origin validation. And we amended the measurement framework and the observatory with those new measurements. This is a landing page. That's what you see when you go to the observatory, the state of routing security, showing number of incidents, number of culprits, and various state of those databases that I mentioned, IRR and RPKI, how full, how complete those databases are. And it also shows what we call menace readiness. And those are 5 donut charts that show how ready the networks operating on the internet are vis-a-vis the menace norm menace baseline. Now, this is a global view, but let us zoom in to the Caribbean region. And here you see maybe slightly different numbers. You can see that while filtering, you didn't experience a lot of incidents. That's a good thing. There is almost no data on anti-spoofing. Again, I didn't speak of anti-spoofing, but that's the only measurement that requires active participation on networks. So if spoofing experiments will not run, then we have no data. We cannot say if networks prevent spoof traffic or not. Scoring quite high on coordination, but not so high on the deployment of RPKI and in particular on ROA registration. So there's some room to grow. And this is just to compare with the menace participants and their readiness scores in the same region. And I have to admit there are only 3 participants. So hope after this presentation, and if there are network operators in the room, I hope I can ignite some interest and motivate them to join this effort. It's free, by the way, but you just need to do your homework. So as you can see, the numbers are much higher here. And this is a graph just to compare different sort of baselines. The red baseline is the menace, and you can see they're much better performing than the global baseline, which is blue, and the Caribbean baseline, which is green. And you see the Caribbean region performs slightly better in some of the areas such as coordination, for instance, and even IRR, but is slightly worse than the global average on RPKI front. So there is some room for improvement here. As I mentioned, menace readiness scores, they're published on the menace website, so you can go and you can see how menace participants, how well they live up to their promise, to their commitment, because we publish those scores. And red indicates you are not ready, and unfortunately we still have participants that are not fully ready. We are working with them. And I am very close to the end of my presentation, so learn more and join us, please, to be ready to prepare for menace. We publish, we have a lot of resources, menace implementation guide that will guide you through all what you need to do to reach those outcomes, to meet the requirements. Also, we have training sources, training resources, training tutorials that you can take free of charge. And I think Internet Society still provides sort of scheduled training courses that also include menace. And let me finish with the question, why join menace? And I think there are 4 important things here to mention. First of all, while, as I said, that implementing routing controls contributes to the overall security of the routing system, it also has a business case for yourself, because you don't want your customer to become your transit provider and start, announcing traffic to Google, which will create a huge outage, I assure you. So improve your security posture and reduce the number of impact of routing incidents. That's already a win. Now, from the community point of view, joining menace will demonstrate that these practices are reality, that you commit to something, you implement something, and you contribute to routing security. manners, it reached certain level of awareness, pretty high level of awareness in operations community. And in many places, it becomes a norm for routing operations. So being part of manners means that you meet those expectations of operators community. And please join us and share your experience and your expertise with the community of security-minded operators. So joining is very simple. You just, well, simple, provided you implement all the necessary controls. Just fill out the form and we'll take it. It's not yes or no answer. We'll work with you. We'll guide you through the whole process and help you on the way. If there's some deficiencies and some inconsistencies, we'll help you to resolve those. And if you have any questions, please contact us and we'll be happy to help you. So those are some URLs of Manners of Global Cyber Alliance, and please follow us on social media. And thank you for having me here at this session. Thank you.
Thank you so much, Andre. Really excellent presentation. And not only the results of Manners today, but also the model that you've been setting up in the community to work with the community, basically get a kind of good understanding within these communities on how best practice looks like and help each other to improve upon it is really something that can be followed in many areas. And if there's any specific questions about this at this moment, yes, please.
Thank you, Rodney Taylor, CTU. I posted it in the chat, but I'll read it anyway. I was asking Andre, he mentioned IXPs and CDNs and so on, and whether or not he was saying as a policy for an IXP, for example, that which we've been promoting in the region, whether there should be some compliance with these standards and norms before operators are allowed to connect on an exchange as a policy.
Thank you. That's a good question. I'm not aware of those policies at IXP that would prevent members to connect if they're not manners compliant. But I know that some of the IXPs, they promote manners in their community and maybe even provide incentives for members that are manners compliant to connect to the internet exchange, with the logic that if you're a manners compliant network, that you will cause less trouble, right? You're less risky, and therefore maintenance and management costs are lower. But I don't think it's maybe a good idea at this stage, at least, to use this as a sort of yes or no gating function. What is also important that IXPs, being a manners participant, they provide their own controls and therefore they clean up the peering environment. So even if non-manners compliant network participates, they will not be able to spread incorrect routing announcements among the peering community. That's the effect of manners IXP program. I hope I answered your question.
I see a thumbs up in the room. Thank you for that. A model that works, if we got an understanding of good or best practice, whether it's the European Union towards new accession states, whether it's manners towards new routing partners, it's always good if people first get up to speed to live up to those standards. I think we see the same in the third area, and with that, another area is also DNS security. And thank you, Andre, very much. We'll now move into the next session, which is about kindness. Keep these manners in the back of your mind if we get back towards action planning. What can we do to stimulate uptake in this region, if you think that makes sense? So for now, manners. Let me give the microphone to my colleague from ICANN, Albert Daniels, and he will also introduce the topic further with Nicholas.
Thank you very much, Martin. We can see that the technical community is becoming very polite with very good manners and also with a lot of kindness. But as expected, these acronyms mean something important with regard to technical standards. And perhaps in a similar way to what has been done with manners, ICANN has come up with the kindness standards, which help organizations to benchmark themselves against best practice. So we have again with us my colleague, Nicolas Antoniello, who's actually in Brazil right now at another event. You will see he's wearing a name tag as well. But Nicolas will talk to us a little bit about manners. He did about kindness. He did start in the first session, but now we will go into a little bit more detail. So Nicolas, over to you.
Thanks very much, Daniel. Normally, I wouldn't be dressing this good. But anyway.
You look emotional now, Nicolas.
Yeah. Okay, so let's talk about kindness. To talk about kindness, I'm going to just recap a little bit about manners. So manners, from me as a technician, has been a huge success in providing, as Andre perfectly explained it, and provided a platform and a framework and a reference in terms of routing best practices. Because manners was a huge success, we at ICANN thought, hey, we don't have a similar framework and tool for DNS server operators to have a kind of easy to go reference on which are the DNS related best practices and to implement or to deploy when they are running any type of DNS server. And so we created this program. We call it Kindness. I'm gonna share a presentation about this and go quite fast through all the program and the features and the tools we have in here. So as I said, it's Kindness is an ICANN initiative. That main goal is to promote DNS operational best practices. Okay. It's an acronym. Again, we love acronyms at ICANN. I do not necessarily share that love for the acronyms, but we have a lot of acronyms in the technical world. So kindness means knowledge sharing and instantiating norms for DNS and naming security. So this we pronounce kindness, and it's basically that. It's basically it aims to be a framework and a platform for operators, for DNS operators reference on DNS operations best practices, including security, including privacy, including many aspects of the operation of a DNS server. Okay, and we mainly divide the whole DNS operational world in two big groups. Okay, those that operate authoritative servers and those that operate resolver or recursive server, as we call them. So if you remember, when earlier today I was talking about the how DNS works, and we talked about two different types of DNS servers. So the authoritative servers, that are the ones that hold all the DNS information. The authoritative servers are the ones that together they form the DNS database. And then the resolvers are the ones that search for information in the DNS database formed by the authoritatives. Okay, so if you run an authoritative server or if you run a resolver, these are the two big groups. We divide the DNS operations in the Kindness program. Let's talk first about the authoritative server operations. So we divide within the authoritative server operations. We divide it in two groups: the ones that run what we call top-level domains or critical zones, and those that run second-level domains. Here it says second-level domains, but it's really any other authoritative server operations. Could be second-level domain, third-level domain on any server that is not necessarily a top-level domain or a critical zone. A top-level domain, it's a domain that is located in the first level of the DNS database tree. You know, the DNS database has we normally represent it as an inverted tree with the root at the top, and then all the levels each level holding as much as we want domains, right? And these top-level domains are the most known domains, like the com, net, org, etc., etc. Those are called the generic top-level domains. And then there are other top-level domains that are assigned one to each country, and those are the so-called country code top-level domains. So the GTLDs, which are the generic top-level domains, and the CCTLDs, country code top-level domains. Those two fall in this first group, top-level domains and critical zone operations. So what's a critical zone? A critical zone could be really anything that the operator classifies as critical. For example, if you run a DNS authoritative server for a health service within your country, or you run a DNS authoritative server for state dependencies, service providers like the ministers, the different dependence of the central administration of the country, that could be considered also a critical zone. If you run an authoritative server for military applications, also that could be considered a critical zone. All of those fall into this first group, TLDs and critical zones. And then it comes any other type of authoritative server operation. Again, it could be second-level domain or any other domain. And then we have, within the resolver operators, we have three subgroups. We divide the resolver operations into these three groups. The first one is what we call the close and private resolver. What's a close and private resolver? A close and private resolver is a resolver, that a recursive server, a DNS resolver, that's used only by a company and only within the company for all the devices or the equipment that lives in the company network. So every device that is in the company network will be using this resolver for DNS resolution, and we call that type of resolver close and private. Why close and private? Because these resolvers are not accessible by anyone else in the internet. They are only accessible from the inside of the network of a certain company or organization. That's why they are closed and private, okay? They, of course, in order for those servers not to be able to be accessed by the public, but anyone in the internet, they are protected by filters. Normally, you put a filter, you set up a filter that says, okay, only these IPs, these source IPs, can access this server. If a request, a DNS query comes from any IP out of that list, the DNS resolver will reject to answer that query, and that's how you end up making that server close and private. Okay. Then we have another subgroup that we call shared private resolvers. These are slightly different from the previous one. A shared private resolver is the type of resolver that ISPs, internet service providers, normally provide for the use of their customers. If I'm connected to the internet from my home, okay, from my house, I have I have fiber to the home. I connect to the internet through an ISP that provides me with a fiber and with a internet access service. And that ISP will normally also provide me a DNS resolver. So anytime any device within my network needs to resolve a DNS query, it will be sending that query to this ISP provided resolver. Those type of resolver, normally ISPs only allow to be used by its customers. So if I'm a customer of a different ISP, I won't be able to use that resolver. If I'm outside there in the internet and I'm not a customer of this specific ISP, I won't be able to use that resolver. That's why we call shared private. They are private because they are only accessible by a small group, not by all the internet. And they are shared because this group, this small group that can access that server is the customers of the specific ISP that is sharing the server with its customers, okay? And then finally, we have a third subgroup, which we call the public resolvers. These are the so-called and well-known public resolvers. These are companies that or organizations that make a resolver available to anyone in the internet. Examples of these public resolvers are, some of them are very well known, like the Google public resolvers. They have this very easy to remember IP 8.8.8.8. We have the Quad 9 public resolvers. They are called Quad 9 because they have the 9.9.9.9 IP address. In order to access them, we have public resolvers provided also by Cloudflare. We have another public resolvers provider. So we have these three subgroups: public, accessible by anyone in the internet; shared private, only accessed normally by customers of a specific ISP or customers of a specific company; and then closed and private, only accessible by members and equipment that lives within an organization or a company network. Okay. Why the kindness program divides in these two big groups and then in subgroups? Because the best common operational practices that applies to a DNS server depends on the type or the kind of DNS server operation that you perform. So it's a slightly bit different set of best practices that you will have to apply if you are running an authoritative server than if you're running a resolver. And then if you're running a resolver, there is a slightly different set of best practices that you should implement depending on if you're running a public, a shared private, or a closed private resolver. That's why we separate the big problem into these smaller groups. So once you identify the group that you belong to, the type of server that you're running, you will in the kindness program you will find a set of best practices that you should be implementing if you're running that type of server. For example, if you're running an authoritative server that falls within the TLDs and critical zones category, this is the set of rules that you should be applying. This set of rules is not that we came up with a set of rules that we decided. It's the kindness program. What we do is we collect the best practices agreed in general by the DNS operations community, and we put it into the program. And the process that we follow in order to have all the set of best practices that we will apply to each group is by an open and community-driven process where we have I will go through that a little in some minutes, but we have a discussion list where anyone willing to be part of this kindness community can apply, can subscribe to that mailing list and discuss which are the best practices, if we need to add some practice to the set of best practices, if we need to remove some practice from the set of best practices, etc., etc. So it's a kind of live and open process that leads to the set of best practices that kindness program will apply to each of the groups. So again, this is an example. This is a set of 7 best practices that you should be deploying if you're running a TLD and critical zones. It says these numbers doesn't mean anything special. It's just to be easier to refer to each practice. It's not that one of these is more important than the other. All of these are equally important. If they are here, it's because they are the agreed best practices, and all of them are equally important. But number one, for example, says, okay, if you're running a TLD and critical zone authoritative server, you must have a DNSSEC security extension in place. So you must deploy DNSSEC security extension as you are running an authoritative server. Of course, this will mean that you will have to sign your zone, that you will have to maintain your private and your public key sets and all the security that you need to have in place and all the processes that you need to have in place in order to be able to run a DNSSEC signed authoritative server. You have to limit the transfer between authoritative servers, primary servers, and secondary servers in order for not to be able to a server which is out of your control to be able to transfer the full zone, etc., etc. Okay, these are a set of rules of best practices. That applies to authoritative server operators that run an authoritative server that does not fall in the previous category. So this is not a TLD nor a critical zone, but it's an authoritative server. So this is the set of best practices that you should be implementing. And going to the resolver operations, this is the set of rules, the set of best practices that you should be deploying if you're running a closed and private resolver, the set of best practices that you should be deploying if you're running a shared private resolver, and the set of best practices that you should be running if you're running an open resolver. Here I think that there's an error because both are saying shared private resolvers. One is for shared private resolvers and the other is for public resolvers. Okay, I will correct this before sending you the presentation. In the kindness program, we have created a site where we publish all the information, all the resources, and all the tools related to the program. And one other, I think, very, very useful and important part of the kindness program is that it provides also tools, configuration examples, explanation of each of the features that you may add or deploy, or that you should be deploying in your infrastructure, not necessarily directly related to DNS, but, for example, in terms of security, how you secure your DNS infrastructure. So that could be not necessarily a DNS protocol extension, but could be a general security rule that you should be applying to your DNS infrastructure, as well as any infrastructure that you're running. So all of those extra tools and resources are under what we call core hardening. And that's like, if you want to go one step beyond the basic set of good practices, you would get into this core hardening, and this will give you more and more tools and recommendations in order to be, to go one step or two or three steps forward. Okay, in terms of resiliency, in terms of security, in terms of privacy of your DNS infrastructure. And let me stop this sharing and share another screen with the kindness site. So this is the kindness website, the kindness.org website, and this is the main screen you will get when you access kindness.org website. And here, if you see, you have a kind of button that it says self-assessment, right? This is one of the most important resources in the website, in the program website. And what you have here is it's a tool, it's an optional tool, of course, that it will give you the opportunity to do a self-assessment. It will ask you for some information, and then it will present you with a basic set of good practices that you should be implementing according to the group you select. For example, if I run a private shared resolver, I select that I run a private shared resolver, and it will be presenting me all the good practices that I should be implementing. And then you have to click on every practice that you are currently implementing, and you left without a click those that you are not yet implementing. At the end of that, it will give you the opportunity to download a report. If you don't download that report and you go forward and you close the screen, no information is going to be stored by the system. So if you do not download the report at the end and you want the report, you will have to go again through all the questions. It's a very, I mean, it takes 5 minutes or less for a technician to run this self-assessment. And the report, it's going to be a PDF that it will generate and you will be able to download. And the report will tell all the good practices that you're already implementing. And from those good practices that you are not yet implementing, it's going to give you an explanation of what that good practice means, what is it, what all the related protocols to that good practices means, how it works, and it will also give you links to basic configuration in case you want to deploy that practice. It will give you examples of configuration for the 5 or 6 most common DNS servers software. So you can just go and try the configuration in your server, learn about it using the links and the information that the report will give you. And then if you feel enough comfortable with the information and the experience you got from there, you can go and deploy the good practices in production. Okay. Finally, the program also has a way to participate in the program, right? And the way for you to participate in the program is after taking the self-assessment. If you comply with at least a subset of all the good practices, you can send that report and you can send an email to us. The email is provided in the website under the Join Us button. And what we will do is we will review all the good practices that your organization is currently implementing, and eventually we will add you to the kindness program participants, and we will give you a kind of it's not a certificate because we are not a certifying organization, but it's a proof that you have gone through this self-assessment, and it's a proof that you comply at least with this set of good practices. And that could be of interest for organization because you can show your customers that you comply with these DNS operation good practices, and it could be an asset for an organization to comply with that. And also it's always, of course, the main goal behind this is to make the whole internet and the whole DNS ecosystem more resilient, more secure, and more trustable by the end users, which is the most important goal after we go after. That's more or less the summary of the program, Martin. I hope I won't take a long time to explain.
Your enthusiasm is clear on this, and rightly so. What we're doing here with kindness, what we're doing here with manners, what we're doing here with trying to understand how our infrastructure could be improved, also using the indicators from the Internet Society, is really to prevent things to go wrong from this internet that we depend on increasingly. And with that, it's really important to draw attention to that of your policymakers, of your business providers, of your operators. I see someone that is very inspired.
Yes, I just wanted to add for the information of our Caribbean that, of course, Kindness is a free program. There's no cost to it. But in addition to that, what ICANN has been doing, particularly in the Caribbean, through one of our partners, Canto, the Caribbean Association of national telecoms operators is Nicholas has actually delivered capacity building and training in this area, allowing the technicians and the engineers from some of the ISPs to learn a little bit more, to go through the steps of doing the self-assessment, to bring them to the level where they can get full advantage of this. And this is actually available to all of our Caribbean territories. Just send us an email, tell us, if you have a group and if you're interested, and we could, help you in that way.
And more questions to Dan, Albert during lunch. Very welcome, and beyond. So with that, I've got 2 questions in the QA pot, and sorry for missing those earlier, but I do want to value those. First, from Dieter Williams, IP version 6 discussions always reminds me of discussions on climate change. In both cases, the situation is presented as critically urgent, and yet that urgency somehow fails to communicate. Any ideas about why? Well, I care a lot about climate change too, and that's just the world that we are starting to slip away. IP version 6 is a little bit less dramatic, but also important. Yet, what we see is that with IP version 4 and all the technical solutions have been found to bridge that over time, it's been extended in its use over time again and again. And continuation of that extension is first in the interest of those who make money out of it, because they have a lot of these addresses and they can sell it. Secondly, it's a big holdback to more secure solutions in which you actually use dedicated numbers rather than shared numbers. And if I look forward to a world that will be even more and more connected, including the IoT devices, including many ways of linking information, you will see that it's inevitable a move there. Whether IP version 4 will be staying something of value for the few that can afford it, who knows? But I see that as something that is not serving the world as large and in the public interest. So let's see that we move from there. Let's have governments embrace that and stimulate that, yet not be careful in mandating it because you don't want to break what you have. So that's the first question. The second question is actually for Nancy. Nancy, how do I get my gift when I share on my social media? Question by Melissa Bukun. If you're not in the room, it might be more difficult, right? You got a microphone on the table. The answer of the woman herself.
Then I think I will have to ask for something more difficult, right? Well, I cannot send it, but you can come here and grab your stuff. Just take a plane.
Thank you so much. By the way, there's also free t-shirts. If you go to internet.nl and your website scores 100% on adoption of all these standards, send your email and you get a free t-shirt. Hard work though. With that, thank you all very much for the contributions from the people online. Some of them will be able to join us later, others will not be. But I think it's been excellent to learn and hear more. Good to see how we, step by step, harden this internet and make it more safe. And whether this region steps up in that is up to you. It's really, you cannot leave that to the global operators alone. You need to link it in, you need to pull it in. And thanks to the CTU and conferences like this, you become more aware and your neighbors become more aware. And together you're pretty strong. And to make sure you're still strong an hour from now, lunch will be served. Please note that after that hour, the speaker online will take you to How do we deal with DDoS attacks? How do we avoid that to cripple our industry in our nation or whatever? And more. So looking forward to see you back in an hour.